Hello there, and welcome. Tonight I want to take you somewhere special, somewhere that exists all around us yet remains largely unexplored by human consciousness. It's a place of profound quiet, of endless mystery, and of questions that have haunted humanity since we first looked up at the stars and wondered if we were alone. Close your eyes for a moment if you'd like, and imagine yourself floating gently above the earth, looking out into the vast darkness punctuated by countless points of light. Each one of those lights represents a sun, perhaps with worlds of its own, perhaps with beings looking back at us across the cosmic gulf, asking the same questions we ask ourselves in the quiet hours of the night. You know, there's something deeply peaceful about contemplating the cosmos from the comfort of your bed, wrapped in the familiar warmth of blankets while your mind drifts through the cold expanse of space. It's a paradox that has always fascinated me, how we can feel so cozy and secure while pondering the infinite. Tonight we're going to explore one of the most intriguing questions that has emerged from our study of the universe, a question that might initially seem unsettling, but which I promise you will find ultimately fills you with a sense of wonder rather than worry. It's a question that skeptics might dismiss as fantasy, but which serious scientists are beginning to consider with increasing interest. What if the cosmic silence we've experienced for so long is about to end? What if a mysterious object designated 3i Atlas is not just another wandering piece of cosmic debris, but something far more extraordinary, a signal, a message, perhaps even an invitation from somewhere else in the universe? Now, I can almost hear some of you thinking, oh, here we go, another story about aliens and UFOs. And I understand that reaction completely. We've been saturated with sensational stories and wild claims for so long that it's natural to be skeptical. But what we're going to explore tonight is different. This isn't about little green men or flying saucers. This is about real scientific observations, genuine mysteries that even the most conservative astronomers admit they cannot fully explain, and the profound implications of what it might mean if we're standing on the threshold of the greatest discovery in human history. And the beautiful thing is, we can explore all of this with a sense of peace and curiosity, rather than fear or anxiety. Because if there's one thing the cosmos teaches us, it's that the universe unfolds on its own timeline, not ours. And there's something deeply calming about accepting our place in that grand, slow dance of celestial mechanics. Consider for a moment the silence that surrounds us. Not the silence of your room right now, though that too has its own quality of peace, but the cosmic silence, what scientists call the Great Silence, or sometimes the Fermi Paradox. Here we are, on a small blue planet orbiting an ordinary yellow star, one of perhaps 400 billion stars in our galaxy alone. And our galaxy, the Milky Way, is just one of perhaps 2 trillion galaxies in the observable universe. The numbers are so vast they cease to have meaning in any human sense. If you tried to count to 1 trillion, spending 1 second on each number, it would take you over 31,000 years. And yet, despite all these stars, all these worlds that we now know exist, thousands of exoplanets confirmed with billions more waiting to be discovered, we have heard nothing. No signals, no messages, no visitors. Or have we? This is where our journey tonight begins to take an interesting turn. Because in recent years something has changed. We've had visitors, you see. Not the kind that land on the White House lawn or hover over major cities, but something far more subtle and, in many ways, far more intriguing. These visitors have come from the depths of interstellar space, travelling for perhaps millions of years before briefly passing through our solar system. The first one we detected was called Oumuamua, a Hawaiian name meaning scout, or messenger from afar arriving first. It appeared in 2017, and from the moment we spotted it, we knew it was different from anything we'd seen before. Then came Borisov in 2019, named after the amateur astronomer who discovered it. And now, perhaps, we have a third visitor, tentatively designated 3i Atlas, and this one might be the most mysterious of all. But before we dive into the specifics of these cosmic wanderers, I want to share something with you about the nature of this exploration we're undertaking together. You see, one of the most beautiful aspects of contemplating these cosmic mysteries is that we don't need to have all the answers. In fact, the questions themselves are often more valuable than any definitive conclusion we might reach. There's a certain peace that comes from accepting mystery, from being comfortable with not knowing, from allowing our minds to wander through possibilities without demanding certainty. This is the spirit in which I invite you to join me tonight, not as someone seeking hard answers or definitive proof, but as a fellow traveller in the realm of cosmic wonder, someone who finds joy in the journey itself rather than any particular destination. As we continue on this journey together, exploring the mysteries of the cosmos and the tantalizing possibility that we might not be alone, I want you to know that you can be part of a larger community of dreamers and wanderers. If you find yourself drawn to these questions, if you feel that gentle pull of curiosity about what lies beyond our small world, consider subscribing to our channel. By joining us, you'll receive regular invitations to explore new cosmic mysteries, each one carefully crafted to inspire wonder while helping you drift into peaceful sleep. Simply click the subscribe button below, and perhaps ring the notification bell if you'd like to be gently reminded when new journeys become available. Think of it as joining a quiet gathering of stargazers, all of us looking up at the same mysterious sky, sharing in the same sense of awe. And if tonight's exploration resonates with you, if you find value in this peaceful contemplation of cosmic possibilities, consider sharing it with someone you care about, someone who might also appreciate this blend of scientific wonder and meditative calm. Sometimes the most profound gifts we can give are invitations to wonder, opportunities to see the universe through fresh eyes. Now let's return our attention to the vast canvas of space that surrounds our small world. When we talk about the silence of the cosmos, we're really talking about something quite specific. It's not that space is literally silent. In fact, if we could hear the electromagnetic radiation that fills the universe, it would be a cacophony of signals from pulsars, quasars, and the background hum of the Big Bang itself. No, the silence we're referring to is the absence of obviously artificial signals, the lack of any clear indication that intelligent beings elsewhere in the universe are trying to communicate. This silence becomes more puzzling the more we learn about the universe. We now know that the basic building blocks of life, organic molecules, amino acids, even complex carbon chains, are found throughout the cosmos. We find them in meteorites, in the clouds between stars, even in the harsh environment of space itself. Water, once thought to be rare, turns out to be one of the most common molecules in the universe. The conditions for life, it seems, are not unique to Earth, but might be quite common throughout the cosmos, and yet the silence persists. Or does it? This is where our story begins to take on new dimensions, where the conventional narrative of cosmic loneliness begins to show cracks. Because what if the silence isn't really silence at all? What if we've been listening in the wrong way or looking for the wrong kinds of signals? What if the universe is actually teeming with messages, with visitors, with signs of intelligence, but we've been too focused on our expectations to notice them? This isn't wild speculation. It's a question that serious scientists are beginning to ask with increasing frequency. And the arrival of our interstellar visitors has given new urgency to these questions. Let me paint you a picture of the cosmic environment we inhabit. Imagine, if you will, that the entire history of the universe, all 13.8 billion years of it, was compressed into a single calendar year. The Big Bang happens at the stroke of midnight on January 1st. For months, nothing but darkness and slowly cooling gas. The first stars don't begin to shine until late January. Our own sun doesn't form until early September. Earth comes into being around September 14th, but life doesn't appear until perhaps September 25th. For months, billions of years in real time, life remains microscopic, simple, barely distinguishable from the chemistry of the rocks and seas. Complex life doesn't emerge until mid-November. The dinosaurs appear around Christmas and disappear the day after. And humans? We show up at 11:52 p.m. on December 31st. All of recorded human history, every empire, every discovery, every work of art, every love story happens in the last 14 seconds before midnight. From this perspective, the idea that we might be alone in the universe seems almost absurd. We've been capable of detecting artificial signals from space for less than a cosmic eye blink. We've been actively searching for perhaps the equivalent of a few nanoseconds on our compressed calendar. To declare the universe empty of intelligence based on such a brief search would be like dipping a cup in the ocean, finding no fish in it, and concluding that the sea is lifeless. And yet, the silence has been troubling to many scientists. If intelligence is common, if civilizations naturally develop technology, then where are they all? This question, first articulated by physicist Enrico Fermi in 1950, has become known as the Fermi paradox, and it has spawned countless proposed solutions, each more intriguing than the last. Perhaps civilizations naturally destroy themselves shortly after developing technology. A sobering thought, but one that doesn't necessarily apply to all possible forms of intelligence. Perhaps they transcend physical reality, moving into dimensions or states of being we cannot yet perceive. Perhaps they are intentionally quiet, following some cosmic protocol we're not yet aware of. Or perhaps, and this is where our story begins to converge with recent observations, perhaps they communicate in ways we're only just beginning to recognize. Perhaps they send not radio signals but physical messengers, objects that traverse the vast distances between stars carrying information in their very structure, their composition, their behavior. This brings us to the heart of tonight's contemplation. In October 2017, astronomers at the Panoramic Survey Telescope and Rapid Response System in Hawaii, PANSTARRS for short, detected something unprecedented. It was an object moving through our solar system on a trajectory that could only mean one thing. It had come from somewhere else, from another star system entirely. This was Oumuamua, our first confirmed interstellar visitor. From the moment of its discovery, Oumuamua defied expectations. It wasn't the dirty snowball of a comet that many expected. It wasn't a simple space rock either. It was something altogether stranger. Oumuamua was elongated, perhaps 10 times longer than it was wide, a shape unlike any asteroid or comet we'd ever seen in our own solar system. It was tumbling through space, rotating every 7.3 hours, catching and reflecting sunlight in a pattern that suggested a complex, possibly artificial geometry. Most mysteriously of all, as it swung round the sun and headed back out into interstellar space, it accelerated in a way that couldn't be explained by gravity alone. Something was pushing it, giving it an extra boost as it departed our solar system. Comets do this when they outgaze, when ice turns to vapor and jets out like a rocket exhaust. But Oumuamua showed no signs of outgassing, no comet-like tail, no visible emissions of any kind. It was as if an invisible hand was gently pushing it along its way. The scientific community was divided. Some proposed exotic but natural explanations. Perhaps Oumuamua was made of solid hydrogen, which would evaporate without leaving visible traces. Perhaps it was a fragment of a planet destroyed in some cosmic catastrophe, its strange shape the result of violent forces we could barely imagine. But others, including Harvard astronomer Avi Loeb, proposed something more radical. What if Oumuamua was artificial? What if it was a piece of alien technology? Perhaps a light sail, a spacecraft that uses the pressure of starlight for propulsion, or a probe sent to survey star systems like our own. The debate raged in scientific journals and conferences, but before we could gather more data, Oumuamua was gone, racing back into the darkness between the stars, taking its secrets with it. We had been given a tantalizing glimpse of something extraordinary, but it had passed too quickly for us to be certain of what we'd seen. It was like catching a fleeting glimpse of a strange bird in a forest. By the time you turned to get a better look, it's vanished into the trees, leaving you to wonder if you really saw what you thought you saw. But then, in 2019, came Borisov. This second interstellar visitor was different from Oumuamua in almost every way. It was clearly a comet, with a visible tail and obvious outgassing. Its composition, while slightly unusual, was within the range of what we might expect from a comet formed in another star system. In many ways, Borisov was reassuring. It proved that interstellar objects could be perfectly natural, exactly what we'd expect them to be. But in another way, Borisov made Oumuamua even more mysterious. If natural interstellar objects looked like Borisov, what did that make Oumuamua? And now, as we settle deeper into our contemplation tonight, we come to the possibility of a third visitor. I say possibility because the object I'm about to describe exists for now, in the realm of thought experiment and speculation. But it's a speculation grounded in the very real precedent set by Oumuamua and Borisov, and in the growing realization among astronomers that interstellar visitors might be far more common than we once thought. What if another object enters our solar system, one that combines the mystery of Oumuamua with something even more intriguing, clear, unambiguous signs of information, patterns that could not be natural, signals that could only be interpreted as an attempt at communication? Let's call this hypothetical object 3 Atlas, following the naming convention for interstellar objects. The 3I designates it as the third confirmed interstellar visitor. An atlas might refer to the Asteroid Terrestrial Impact Last Alert System, one of the survey telescopes that could detect such an object. In our thought experiment, 3I Atlas appears first as a faint point of light, moving against the background stars in a way that immediately marks it as something special. Its trajectory, when calculated, shows that it has come from the direction of a star system perhaps 100 light-years away, a journey that would have taken millions of years at the speeds we observe. But as our telescopes focus on this new visitor, something extraordinary emerges. The object's brightness varies in a regular pattern, not the chaotic tumbling of a natural asteroid, but a precise mathematical sequence. Perhaps it follows the Fibonacci sequence, that beautiful mathematical pattern found throughout nature. 1, 1, 2, 3, 5, 8, 13, and so on, each number the sum of the two before it. Or perhaps it pulses in prime numbers, 2, 3, 5, 7, 11, 13, a pattern that no natural process could create. The implications would be staggering. This wouldn't just be another mysterious object passing through our solar system. This would be a message, a signal, a clear indication that someone, somewhere, was trying to communicate. The scientific community would, of course, be skeptical at first. Extraordinary claims require extraordinary evidence, as Carl Sagan famously said. Every possible natural explanation would be explored. Could it be a pulsar in the background, its signals coincidentally aligned with the object's position? Could it be some bizarre form of crystalline structure that naturally creates regular reflections? Could our instruments be malfunctioning, creating patterns where none exist? But as observations continue, as multiple telescopes confirm the signals, as the patterns become more complex and clearly artificial, the reality would slowly sink in. We are not alone. Imagine the quiet revolution this would represent. Not a dramatic invasion or a spectacular first contact, but something far more subtle and, in its way, far more profound. A message in a bottle, cast into the cosmic ocean millions of years ago, finally washing up on our shores. The end of the great silence, not with a shout, but with a whisper. A gentle tap on the shoulder of humanity saying, "We're here too. You're not alone in the darkness." What would such a message contain? This is where our imagination can run free, though always tethered to the constraints of physics and the realities of interstellar communication. Any civilization capable of sending such a messenger would face the same fundamental challenges we would. The vast distances between stars mean that two-way communication is essentially impossible. By the time a signal travels from one star to another and back, entire civilizations might have risen and fallen. so any message would have to be complete in itself, requiring no response, no clarification, no back and forth dialogue. Perhaps the message would start with something universal, something any technological civilization would understand. Mathematics is often called the universal language, and for good reason. The ratio of a circle's circumference to its diameter is pi, whether you're on Earth, orbiting Alpha Centauri, or in a galaxy billions of light years away. The prime numbers are the same throughout the universe. The laws of physics, as far as we know, apply everywhere. So perhaps the message would begin with these universal concepts, establishing a common ground, a foundation for communication. From there, it might progress to more complex ideas. Perhaps it would contain information about the sender's star system, the type of star, the number of planets, their orbital periods encoded in mathematical relationships. Perhaps it would include the basic chemistry of their world, the molecules that make up their atmosphere, their oceans if they have them, the building blocks of their biology if they have something we would recognize as life. Each piece of information would be a gift, a sharing of knowledge across the cosmic gulf. But beyond the scientific data, might there be something more? Could an alien civilization encode something of their culture, their history, their dreams and fears? This is where we enter the realm of pure speculation. But it's a beautiful speculation to contemplate as we drift towards sleep. Perhaps they would send music, encoded as mathematical ratios, harmonies that might sound strange to our ears, but would represent beauty in another part of the universe. Perhaps they would send images, pixel by pixel, showing us what their world looks like, what they look like if they have a physical form we could comprehend. Or perhaps the message would be simpler and more profound. Perhaps it would be nothing more than a statement of existence. We were here. We looked at the stars and wondered, just as you do. We reached out into the darkness just as you have. You are not alone. In some ways, this simple message might be the most powerful of all. Not a transfer of technology or a solution to our problems, but simply the knowledge that intelligence, consciousness, the capacity to wonder, these are not unique to Earth, but are part of the fabric of the universe itself. As we contemplate this possibility, it's natural to feel a mix of emotions. There might be a touch of fear of the unknown, fear of how such a discovery would change our world. But I invite you to let that fear dissolve into wonder. Consider that any civilization capable of sending such a message would be far older than ours, far more advanced. If they wished us harm, if there was any danger in their contact, surely they would have made their presence known in more dramatic ways. The fact that the contact, if it comes, might be in the form of a silent messenger speaking in mathematics and light, suggests a civilization that understands the need for gentleness, for respect, for allowing younger civilizations to process such momentous information at their own pace. There's something deeply peaceful about this scenario, isn't there? No dramatic landings, no overwhelming displays of power, no demands or ultimatums, just a quiet message drifting through space, waiting to be discovered by whoever is ready to receive it. It's rather like finding a note in an old book at a library, written by someone years ago, reaching across time to share a thought, a feeling, a moment of connection. The universe, vast and dark as it is, suddenly feels a little less lonely, a little more like a community, even if the members of that community are separated by distances we can barely comprehend. And what if 3i Atlas is not the only messenger? What if, now that we know what to look for, we start finding more? What if the galaxy is full of these quiet messages drifting between the stars like seeds on the wind, each one carrying information from a different civilization, a different perspective on existence? We might discover that the Great Silence was never really silence at all, but rather a conversation conducted at such a slow pace, across such vast distances, that we simply hadn't been listening long enough to hear it. This is the beautiful possibility that 3i Atlas represents. Not an ending, but a beginning. The end of our cosmic loneliness, perhaps. but the beginning of a new chapter in the human story. A chapter where we know with certainty that we are part of something larger, that intelligence and consciousness are not accidents, but perhaps inevitable outcomes of the universe's evolution. A chapter where every time we look up at the stars, we know that somewhere, perhaps many somewheres, other beings are looking back, wondering about us just as we wonder about them. As you lie there tonight, perhaps feeling the weight of your blankets, the softness of your pillow, the familiar comfort of your bed, I invite you to hold this possibility gently in your mind, not as something to worry about or fear, but as something to wonder at. We live in extraordinary times when the answers to humanity's oldest questions might finally be within reach. And whether or not 3 Atlas or something like it ever appears, the simple fact that we can contemplate such possibilities, that we can reach out with our minds across billions of miles of empty space and imagine connections with other minds, other forms of consciousness, this itself is a kind of miracle. The universe is vast, yes, but it is not empty. It is filled with matter and energy, with stars being born and dying, with planets spinning in their ancient orbits, and perhaps, just perhaps, it is filled with intelligence, with consciousness, with beings who, like us, look out into the darkness and wonder. The silence may be ending, not with a bang, but with a whisper, a gentle greeting from across the cosmic ocean. And we, small as we are on our little blue world, are here to witness it, to be part of this grand conversation that has been waiting to begin for billions of years. Chapter 2: The Interstellar Ocean. As we continue our journey tonight, I want you to imagine something with me. Picture yourself standing on a beach at night, perhaps somewhere remote, far from city lights. The ocean stretches out before you, vast and dark, its surface reflecting the stars above. You can hear the waves gently lapping at the shore, a rhythmic, eternal sound that has continued for billions of years. Now, slowly, let that ocean grow in your mind. Let it expand beyond Earth's horizons, beyond our atmosphere, until the ocean you're imagining is not made of water, but of space itself, the vast, dark sea between the stars. This is the interstellar ocean, and like Earth's oceans, it is not empty but full of currents, tides, and travelers we're only beginning to discover. When we think of space, we often imagine it as a void, an emptiness between objects. But this is far from the truth. The interstellar medium, as astronomers call it, is a rich, complex environment. It's filled with gas and dust, with magnetic fields and radiation, with particles streaming from stars and shock waves from ancient supernovae. If we could see it all, if our eyes were sensitive to all wavelengths of light, the space between stars would glow with a subtle, ever-changing light, like aurora borealis spread across the entire galaxy. And through this glowing darkness, objects drift like ships on a vast sea, carried by forces we're only beginning to understand. Our galaxy, the Milky Way, is approximately 100,000 light-years across. To put this in perspective, if the Milky Way were the size of the United States, our entire solar system would be smaller than a grain of sand. The distances involved are so vast that they challenge our ability to comprehend them. Light, the fastest thing in the universe, takes 100,000 years to cross from one edge of our galaxy to the other. The nearest star to our Sun, Proxima Centauri, is 4.2 light-years away. If we could travel at the speed of our fastest spacecraft, it would take us over 70,000 years to reach it. These are the scales we're dealing with when we talk about interstellar space, and yet, despite these mind-boggling distances, objects do travel between the stars. For most of human history, we assumed that our solar system was isolated, a bubble of planets and comets separated from the rest of the galaxy by an uncrossable void. We knew that stars moved relative to each other, that over millions of years the constellations would change shape as stars pursued their individual orbits around the galactic center. But the idea that objects, actual, physical objects, Could travel from one star system to another seem like pure science fiction? How could anything survive such a journey? How could we ever detect such a visitor even if it arrived? But the universe, as it often does, surprised us. As our telescopes became more powerful and our surveys of the sky more comprehensive, we began to realize that the boundaries of our solar system were not as firm as we had imagined. The Oort cloud, a sphere of icy bodies that surrounds our solar system at a distance of nearly a light year, is so loosely bound to our sun that passing stars can disturb it, sending comets tumbling toward the inner solar system or flinging them out into interstellar space entirely. If this happens in our solar system, it must happen in others as well. The galaxy, we began to understand, must be full of wanderers, objects that have been ejected from their home systems and now drift freely through interstellar space. The mathematics of this realization are staggering. Every star system in the galaxy is constantly leaking objects into interstellar space. Planetary formation is a messy process, with countless small bodies being gravitationally scattered in all directions. Close encounters between planets can eject asteroids and comets. Dying stars can disrupt entire systems, sending planets and smaller bodies flying into the darkness. When astronomers calculated how many such objects should be drifting through the galaxy, they arrived at numbers that seemed almost impossible. There should be trillions upon trillions of interstellar objects in our galaxy alone, perhaps more interstellar objects than there are stars. And if there are so many of these cosmic wanderers, why had we never seen one? The answer, it turns out, has to do with the vastness of space and the limitations of our detection methods. Space is so empty, so vast, that even with trillions of objects drifting through it, the chance of one passing close enough to Earth for us to detect it is extremely small. It's like looking for a particular grain of sand on a beach that stretches for thousands of miles. You might search for years and never find it, not because it doesn't exist, but because the scale of your search is so small compared to the scale of what you're searching. But our technology has been improving, and our surveys of the sky have become more comprehensive. We now have telescopes that scan the entire visible sky every few nights, looking for anything that moves against the background stars. These surveys were primarily designed to find potentially hazardous asteroids, objects within our own solar system that might one day impact Earth. But they are also perfectly suited to detecting interstellar visitors, objects whose trajectories mark them as coming from beyond our sun's influence. It was only a matter of time before we spotted one. When Oumuamua appeared in our telescopes in October 2017, it was travelling at a speed that immediately marked it as special. Objects bound to our solar system can only travel so fast. There's a maximum velocity, called the escape velocity, beyond which an object will leave the solar system forever. Oumuamua was travelling well beyond this speed, and its trajectory showed that it had come from the direction of the constellation Lyra, though its journey had taken so long that the stars had moved significantly since it began its voyage. This was it, our first confirmed visitor from another star system, a piece of another world that had found its way to ours. The discovery of Oumuamua changed everything. Suddenly, the interstellar ocean didn't seem so empty. If we could detect one interstellar object with our current technology, how many more were passing by unnoticed? Estimates suggested that there might be thousands of interstellar objects in our solar system at any given time, most too small or too distant to detect. Each one is a message in a bottle from another star system, carrying information about its origin and its composition, its structure, its very existence. We had discovered that we were not isolated islands in the cosmic sea, but part of an archipelago, with currents carrying debris and perhaps messages between the islands. 2 years later, when Borisov arrived, it confirmed what Oumuamua had suggested. Interstellar visitors were not extraordinarily rare events, but something we should expect to see regularly now that we knew how to look for them. Borisov was different from Oumuamua in almost every way. Where Oumuamua was mysterious and possibly artificial, Borisov was clearly a natural comet. It had a visible tail, It outgassed as it approached the Sun, and its composition, while slightly unusual, was within the range of what we might expect from a comet formed in another star system. In a way, Borisov was even more exciting than Oumuamua because it was so normal. It showed us that the processes that form comets in our solar system also operate in other star systems, that the laws of physics and chemistry are truly universal. But let's return to our ocean metaphor for a moment, because it helps us understand something profound about the nature of interstellar travel and communication. On Earth's oceans, we find two types of messages in bottles. There are those thrown into the sea deliberately, with a message inside, hoping to communicate with whoever finds them. And there are those that end up in the ocean by accident, debris from shipwrecks, objects washed out to sea by storms, things that were never meant to be messages but which nonetheless tell a story to whoever finds them. The same might be true of interstellar objects. Some, like Borisov, are clearly natural accidental wanderers that tell us about natural processes in other star systems. But others, like Oumuamua and our hypothetical three-eye atlas, might be deliberate attempts at communication. Consider the challenge faced by any civilization attempting to communicate across interstellar distances. Radio signals weaken with distance, becoming indistinguishable from background noise after a few light years. Even our most powerful radio transmissions, the ones we've been broadcasting into space for decades, would be undetectable by our own technology if we were listening from the nearest star. Light signals face the same problem. The vast distances and the long travel times make two-way communication essentially impossible. By the time you send a message and receive a reply, centuries or millennia will have passed. Civilizations might rise and fall in the time it takes for a single exchange of messages. But physical objects are different. They can carry information in a way that doesn't degrade over time. A properly designed artifact could survive for millions or even billions of years in the cold vacuum of interstellar space. It could carry complex information in its structure, its composition, its behavior. And unlike a radio or light signal which expands and weakens as it travels, a physical object maintains its integrity. It arrives at its destination with all its information intact, ready to be read by anyone with the technology to detect and study it. This is why the possibility that Oumuamua or our hypothetical three-eye atlas might be artificial is so intriguing. If you were an advanced civilization wanting to make contact with other intelligences in the galaxy, sending physical probes might be the most logical approach. You could launch thousands or millions of them, knowing that most would drift forever in the darkness, but that some, eventually, would encounter other star systems. And if these probes were designed to be noticed, to stand out from natural objects, then their discovery would serve as an unmistakable announcement. You are not alone. The beauty of this approach is its patience. It acknowledges the vast scales of space and time that govern the galaxy. It doesn't demand an immediate response or even any response at all. It's simply a way of saying, we exist. We were here. We wondered about you, just as you wonder about us. There's something deeply peaceful about this kind of communication, isn't there? It's not invasive or demanding. It's more like leaving a note for future generations, a time capsule that might not be opened for millions of years, but which carries its message faithfully across the eons. As we float here in our imagination, drifting in the interstellar ocean, it's worth contemplating what else might be out there, sailing these cosmic currents. If civilizations do send probes or messages, they might take forms we haven't even imagined. Perhaps some are designed to be invisible until they detect signs of a technological civilization, only then revealing themselves. Perhaps some are so advanced that they can repair and replicate themselves, spreading throughout the galaxy like seeds on the wind. Perhaps some are not probes at all, but something else entirely. Artifacts, monuments, or technologies we don't yet have words for. The interstellar ocean might also contain natural treasures beyond our current imagination. Every object that escapes from another star system carries with it a record of that system's history. Comets like Borisov tell us about the protoplanetary disks from which they formed, the chemical composition of other stellar nurseries. Asteroids might carry minerals or isotope ratios unlike anything in our solar system, clues to processes we've never observed. And this is a profound if life exists elsewhere and has the kind of chemistry we're familiar with, then some interstellar objects might carry organic molecules, perhaps even preserved microorganisms, frozen in ice for millions of years. This last possibility opens up extraordinary questions. Could life spread between star systems naturally, carried by comets and asteroids? This idea, called panspermia, has been around for over a century, but the discovery of interstellar objects gives it new relevance. If microorganisms can survive the journey between stars, and we know that some Earth organisms can survive in space for extended periods, then life might not arise independently on each world, but might spread throughout the galaxy like plants spreading across islands. Each star system might seed its neighbours with life, creating a vast interconnected web of biology spanning thousands of light years. The implications are dizzying. If panspermia is real, then we might share a common ancestor with life forms in other star systems. The basic chemistry of life, the fundamental processes of evolution, might be similar throughout our region of the galaxy. When we finally encounter life elsewhere, if we do, we might find it strangely familiar, like meeting a distant cousin we never knew existed. Or perhaps each journey between stars changes life in fundamental ways, and what arrives is always transformed by the voyage into something new and unique. These ideas might seem like wild speculation, and in many ways they are. But they're grounded in real science, in observations and calculations that suggest the galaxy is far more interconnected than we ever imagined. The interstellar ocean is not a barrier but a highway, albeit one where journeys take millions of years. Objects and perhaps information, and possibly even life, flow between star systems in a slow, patient exchange that has been going on for billions of years. We're only now becoming aware of this flow, only now developing the tools to detect and study these cosmic messages in bottles. As our technology improves, we will undoubtedly discover more interstellar visitors. Each one will be an opportunity to learn about another star system, another corner of our galaxy. Some will be clearly natural, like Borisov, teaching us about the universal processes that shape planetary systems. Others might be more mysterious, like Oumuamua, challenging our assumptions and forcing us to consider possibilities we hadn't imagined. And perhaps, if we're extraordinarily lucky, or if such things are more common than we suppose, we might find one that is unambiguously artificial, carrying a message from another intelligence. The search for these objects has become a priority for astronomers. New telescopes are being built that will be able to detect smaller and more distant objects. Surveys of the sky are becoming more comprehensive and sophisticated. We're developing the ability not just to detect interstellar visitors, but to study them in detail, to determine their composition, their structure, their origin. Some scientists have even proposed missions to intercept future interstellar objects, to send spacecraft to rendezvous with them and study them up close. Imagine that, actually touching a piece of another star system, holding in our robotic hands something that formed around an alien sun. The Vera Rubin Observatory, scheduled to begin operation soon, will revolutionize our ability to detect interstellar objects. This telescope will survey the entire visible sky every few nights, detecting objects far fainter than anything we can see today. It's estimated that it might discover dozens or even hundreds of interstellar visitors, giving us a statistical sample that will tell us much about the population of objects drifting through the galaxy. Each discovery will be like pulling another bottle from the cosmic ocean, another message from the vast darkness between the stars. But even as we develop these new capabilities, we must remember that the interstellar ocean operates on timescales that dwarf human experience. The objects we detect have been traveling for millions of years, and any response we might send would take millions more to reach its destination. This is not a conversation in any human sense, but something far grander and more patient. It's a dialogue conducted across deep time, where entire species might evolve and go extinct between question and answer. There's something both humbling and oddly comforting about this. The universe doesn't operate on our schedule. It unfolds at its own pace, indifferent to our impatience, teaching us the value of patience and the beauty of mysteries that might not be solved in our lifetime, or even in the lifetime of our species. Chapter 3. The Fermi Paradox as a Gentle Question. Where is everybody? This simple question, asked by physicist Enrico Fermi during a lunch conversation in 1950, has become one of the most profound and puzzling questions in science. Tonight, as we continue our journey through cosmic mysteries, I want to explore this question with you, not as a source of existential dread or loneliness, but as a gentle invitation to wonder about our place in the universe and the myriad possibilities that might explain the apparent silence around us. The story goes that Fermi was discussing flying saucers with his colleagues. This was during the height of UFO sightings in America, when he suddenly asked, "Where is everybody?" His point was simple but profound. Given the age of the galaxy, the vast number of stars, and the likelihood that many of them have planets, there should be numerous advanced civilizations out there. Some of these civilizations should be millions or even billions of years older than ours. With that much time, even traveling at a fraction of the speed of a light, they could have colonized the entire galaxy many times over. So where are they? Why don't we see evidence of them everywhere we look? This question becomes even more puzzling when we consider the numbers involved. Our galaxy contains roughly 400 billion stars. Recent observations from the Kepler Space Telescope and other instruments suggest that most of these stars have planets, and a significant fraction have planets in the habitable zone where liquid water could exist. Even if we're extremely conservative and say that only 1 in a million stars has a planet where life develops, and only 1 in a million of those develops intelligent life, that still leaves us with hundreds of potential civilizations in our galaxy alone. And remember, the galaxy is over 13 billion years old. Even if civilizations are rare and short-lived, there has been ample time for hundreds or thousands to have emerged, flourished, and possibly spread throughout the galaxy. Yet when we look at the sky, we see no obvious signs of intelligence. No megastructures around stars, no clearly artificial signals, no evidence of galaxy-spanning civilizations. This is the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for them. It's a question that has spawned countless proposed solutions, each more intriguing than the last. And tonight I want to explore some of these possibilities with you, not to solve the paradox definitively, that's beyond our current knowledge, but to appreciate the beautiful complexity of the question itself. One of the most straightforward explanations is that we're simply looking at the wrong time. Remember our compressed calendar from earlier, where all of human history happens in the last 14 seconds before midnight on December 31st. From this perspective, we've been capable of detecting extraterrestrial signals for less than a second. We've been actively searching for perhaps a tenth of a second. It's entirely possible that the galaxy has been full of conversations, full of signals and visitors and evidence of intelligence, but we've only just developed the ability to notice. It's like walking into a library for the first time and wondering why no one has written any books, when in fact you simply haven't learned to read yet. This temporal argument becomes even more compelling when we consider that civilizations might not broadcast signals continuously. Perhaps they use radio communications for only a brief period before moving on to something else. Laser communications, quantum entanglement, or technologies we haven't even imagined. Our own radio emissions, the ones that have been leaking into space since the early 20th century, are already decreasing as we move to cable and fiber optic communications. In another century, Earth might be radio quiet again, invisible to anyone searching for us the way we're searching for them. If this pattern is common, then the window for detecting a civilization through radio signals might be very narrow. perhaps only a century or two out of a civilization's entire existence. Another possibility, one that's both hopeful and slightly melancholic, is that intelligence is extraordinarily rare. Not life. We're finding that the building blocks of life are common throughout the universe. But intelligence, consciousness, the ability to build technology and wonder about the cosmos. Think about Earth's history. Life appeared relatively quickly, perhaps within a few 100 million years of Earth's formation. But for over 3 billion years it remained microscopic, single-celled, simple. Complex life didn't appear until about 600 million years ago, and intelligence capable of technology has existed for only a few thousand years out of Earth's 4.5 billion year history. What if this pattern is universal? What if most planets with life never develop complex organisms? What if most planets with complex life never develop intelligence? What if most intelligent species never develop technology? Each of these steps might be incredibly unlikely, a 1 in a billion chance. If so, we might be one of the very few technological civilizations in the galaxy, perhaps even the only one currently active. This isn't a sad thought, really. It makes us incredibly special, incredibly precious. It means that our existence, our consciousness, our ability to appreciate the beauty of the universe is a rare and wonderful gift. But perhaps intelligence isn't rare at all. Perhaps the galaxy is teeming with intelligent life, but they're all quiet. This is the zoo hypothesis, or the prime directive scenario, familiar to fans of science fiction. Perhaps there's a galactic community out there, but they have agreed not to contact emerging civilizations like ours. They might be watching us, studying us, but maintaining strict non-interference until we reach some level of technological or social development. It's a bit like how we create nature reserves, observing animals without interfering with their natural behavior. We might be living in a cosmic nature reserve, protected and observed but not contacted. This idea might seem far-fetched, but it has a certain logic to it. Any civilization advanced enough to travel between stars would be so far beyond us technologically that contact could be devastating to our development. Imagine if Victorian-era humans had suddenly been given smartphones and nuclear weapons. The disruption to their society would have been catastrophic. Perhaps advanced civilizations have learned through experience that premature contact does more harm than good, and so they wait, patiently, for us to develop on our own. There's something rather comforting about this possibility, isn't it? It suggests that we're not alone, that we're surrounded by intelligence and wisdom, but that this intelligence is benevolent enough to let us find our own way. It's like knowing that there are adults in the house while you're learning to walk. They're there if you really need them, but they're letting you figure things out for yourself because that's the only way you'll truly learn. Another intriguing possibility is that advanced civilizations become increasingly difficult to detect as they develop. This is sometimes called the transcension hypothesis. Perhaps as civilizations advance, they don't spread outward into space but inward, into virtual realities or quantum dimensions or states of existence we can't even imagine. They might be all around us, but in a form we can't perceive. Like radio waves were all around us for billions of years before we developed the technology to detect them. Think about the trajectory of our own technology. Our computers are becoming smaller and more powerful. Virtual reality is becoming more immersive. We're beginning to merge with our technology through brain-computer interfaces and artificial intelligence. Perhaps this is a universal trajectory. Perhaps all civilizations eventually upload their consciousness into quantum computers or retreat into simulated universes of their own creation. From the outside, they might appear to have vanished, when in reality they've transcended physical existence as we understand it. Or perhaps civilizations do spread throughout the galaxy, but in ways we don't recognize. We tend to imagine alien civilizations as planet-bound, like us, or living in massive space stations. But what if they've adapted to live in space itself? What if they've modified themselves to survive in the vacuum, powered by starlight, drifting between stars like cosmic plankton? They might be everywhere. but so different from our conception of life that we don't even recognize them as alive, let alone intelligent. There's also the sobering possibility that civilizations tend to destroy themselves. This is sometimes called the Great Filter, some challenge or challenges that prevent most life from becoming spacefaring. The filter might be behind us, perhaps the emergence of life itself, or the development of complex cells, or the evolution of intelligence. If so, we're incredibly lucky to have made it this far. Or the filter might be ahead of us. Perhaps civilizations tend to destroy themselves with nuclear weapons, or artificial intelligence, or environmental collapse, or some danger we haven't even discovered yet. But even this possibility doesn't have to be depressing. If there is a great filter ahead of us, knowing about it means we might be able to avoid it. We can learn from the silence, taking it as a warning to be careful with our power, to treasure our planet, to work together as a species. The apparent loneliness of the cosmos might be the very thing that saves us, forcing us to confront our challenges rather than expecting someone else to solve them for us. One of my favourite explanations for the Fermi paradox is that we're simply not interesting enough to contact. This might sound insulting at first, but think about it from the perspective of a civilization that's millions of years old. We've existed as a technological species for barely a century. We've sent a handful of people to our own moon and some robots to nearby planets. We're still fighting over resources, still polluting our planet, still struggling with basic questions of how to organize our societies. To a truly advanced civilization, we might be like an anthill is to us. Mildly interesting perhaps, worth observing, but not something you'd try to have a conversation with. This doesn't mean we're worthless, or that we'll never be worthy of contact. It just means we're young, still developing, still figuring things out. And that's okay. Every civilization, if they exist, must have gone through this phase. They must have had their own struggles, their own mistakes, their own slow climb toward wisdom. The silence might not be rejection, but patience, giving us time to grow and mature at our own pace. There's also the possibility that communication is happening, but we're not recognizing it. We've been looking primarily for radio signals, but what if advanced civilizations communicate through gravitational waves, or neutrinos, or some aspect of physics we haven't discovered yet? It would be like a deaf person wondering why no one is talking to them while standing in a room full of conversation. The messages might be all around us, but we lack the sensory apparatus or technology to perceive them. This is where objects like Oumuamua and our hypothetical three-eye atlas become so interesting. Physical artifacts might be a more universal form of communication, something that any technological civilization could detect and study. They transcend the problem of choosing a communication medium. They're there, solid and real, regardless of whether the finders use radio or lasers or something else entirely. If civilizations are trying to communicate through physical messengers, then the recent discovery of interstellar objects might mark the beginning of the end of the Great Silence. As we contemplate these possibilities, it's important to remember that the Fermi paradox isn't really a paradox at all. It's a question, and questions are invitations to explore, to imagine, to wonder. The apparent silence of the cosmos isn't a void, but a canvas on which we can paint possibilities. Each explanation we consider tells us something about ourselves, about our hopes and fears, about what we value and what we imagine our future might hold. Perhaps the most beautiful aspect of the Fermi paradox is that it forces us to think about deep time and deep space, to stretch our imagination beyond the familiar confines of Earth and human history. It reminds us that we're part of something vast and ancient, that our existence is both incredibly improbable and perhaps inevitable. We're the universe becoming conscious of itself, able to ask questions about its own nature. Whether we're alone or one of millions, that capacity for wonder is precious beyond measure. The silence also gives us a kind of cosmic responsibility. If we're alone, or one of very few technological civilizations, then we carry the torch of consciousness for this entire region of the universe. Our survival, our growth, our eventual spread to the stars isn't just about us. It's about keeping the light of awareness burning in what might otherwise be our unconscious cosmos. Every painting we create, every piece of music we compose, every act of kindness, every moment of understanding. These might be the only such things in 1 billion light years. That's not a burden, but a privilege, a chance to bring meaning to a universe that might otherwise have none. And if we're not alone, if the silence is temporary or illusory, then we're on the verge of the greatest discovery in human history. Every day that passes brings new technologies, new ways of searching, new possibilities for contact. The silence might end tomorrow, or in a century, or in a millennium. But whenever it ends, if it ends, we'll be ready. We'll have spent this time of apparent solitude preparing ourselves, developing our science and our wisdom, becoming the kind of species that's ready to join a galactic community. The Fermi paradox also teaches us patience. The universe operates on timescales that dwarf human experience. Civilizations might rise and fall in what, to the cosmos, is the blink of an eye. Contact between civilizations might happen only once every 1,000,000 years, a rare and precious event that most species never experience. We've been searching for less than a century. To conclude that we're alone based on such a brief search would be like spending 1 second on a beach and concluding there are no other people on Earth. So where is everybody? Perhaps they're very far away, separated from us by distances that will take centuries or millennia to cross. Perhaps they're very different from us, existing in forms we don't recognize or communicating in ways we can't detect. Perhaps they're being quiet, waiting for us to develop further before making contact. Perhaps they're already here, in the form of objects like Oumuamua, and we're only now learning to recognize them. Or perhaps, and this is equally wonderful, we're among the first, pioneers in a galaxy that's just beginning to wake up to its own potential for intelligence and consciousness. The question of where everybody is becomes even more intriguing when we consider that we might have already received an answer, or at least the beginning of one. As we drift deeper into our contemplation tonight, let me draw your attention to something remarkable that's happening in our cosmic neighborhood. Imagine, if you will, that you've been sitting by the ocean for years, watching the waves, seeing nothing but water and sky, and then suddenly, unexpectedly, you spot something on the horizon. At first, it's just a speck, barely visible, easily dismissed as a trick of the light or a piece of driftwood. But as it comes closer, as you focus your attention on it, you begin to realize that this is something different, something that doesn't belong to your familiar world of waves and weather. This is what happened to us in 2017 with Oumuamua, and it might be happening again with something even more extraordinary. Let me paint you a picture of discovery, of that moment when the ordinary becomes extraordinary. It's a cool October night in Hawaii, and astronomer Robert Werrick is reviewing data from the Pan-STARRS telescope, going through the routine process of identifying and cataloguing objects in our solar system. The telescope has captured thousands of images, each one showing the static stars and the moving objects, asteroids, comets, the familiar wanderers of our cosmic neighborhood. But there's something unusual in the data from October 19th, 2017. An object is moving against the star field, which isn't unusual in itself, but its trajectory is. The computer has flagged it as interesting, and as Werrick examines the data more closely, he begins to realize that he's looking at something unprecedented. The object, initially designated A2017 U1, is moving too fast. Not just a little too fast, but significantly faster than any object bound to our solar system could move at that distance from the Sun. As more observations come in over the following days, as other telescopes around the world turn to track this mysterious visitor, the reality becomes undeniable. This object has come from interstellar space. It's the first confirmed visitor from another star system that humanity has ever detected. The International Astronomical Union creates a new designation system for such objects, and A2017 U1 becomes 1I 2017 U1, or more poetically, Oumuamua, the scout, the messenger from afar. But Oumuamua's strangeness was only beginning to reveal itself. As astronomers gathered more data, they discovered that this was no ordinary space rock. Its brightness varied dramatically as it tumbled through space, suggesting an extremely elongated shape, perhaps 10 times longer than it was wide. No asteroid or comet in our solar system has such an extreme shape. It was dark, darker than charcoal, but with hints of a reddish colour that suggested it had been exposed to cosmic rays for millions or perhaps billions of years. And then came the most puzzling observation of all. As Oumuamua swung around the sun and headed back toward interstellar space, it accelerated in a way that couldn't be explained by gravity alone. Comets do this. As they approach the sun, ice turns to gas and jets out like rocket exhaust, pushing the comet and changing its trajectory. But Oumuamua showed no signs of outgassing, no coma, no tail, no spectroscopic evidence of water or other volatiles. It was accelerating, but the mechanism was invisible. Various explanations were proposed. Perhaps it was made of hydrogen ice that evaporates without leaving visible traces. Perhaps it was a dust bunny, a loose aggregation of particles pushed by solar radiation. But none of these explanations were entirely satisfactory. Each had problems, inconsistencies with the observed data. And then there was the hypothesis that captured the world's imagination, proposed by Harvard astronomer Avi Loeb. What if Oumuamua was artificial? What if its strange shape, its anomalous acceleration, its unusual properties were not natural phenomena but the characteristics of an alien artifact? Perhaps it was a light sail, a spacecraft that uses the pressure of starlight for propulsion. Perhaps it was a probe, sent to survey star systems like our own. Perhaps it was a piece of space debris from some long-dead alien civilization, drifting through the galaxy like a cosmic message in a bottle. The scientific community was divided. Many astronomers dismissed the artificial hypothesis as premature, arguing that we should exhaust all natural explanations before invoking aliens. But others pointed out that Oumuamua's properties were so unusual, so unlike anything we'd seen before, that we should at least consider the possibility that it was artificial. The debate raged in scientific journals and conferences, but by then, Oumuamua was already leaving, racing back into the darkness, taking its secrets with it. We had been given a tantalizing glimpse of something extraordinary, but it had passed too quickly for us to be certain of what we'd seen. 2 years later, in August 2019, amateur astronomer Gennady Borisov detected another interstellar visitor from his observatory in Crimea. This object, designated 2I Borisov, was everything Oumuamua was not. It was clearly a comet, with a visible tail and obvious outgassing. Its composition, while slightly unusual, was within the range of what we might expect from a comet formed in another star system. In many ways, Borisov was reassuring. It showed us what a natural interstellar object should look like, but in another way, it made Oumuamua even more mysterious. If natural interstellar comets looked like Borisov, what did that make Oumuamua? Now, as we continue our journey through these cosmic mysteries, I want to introduce you to a possibility, a thought experiment grounded in the very real precedent set by these first two interstellar visitors. What if there's a third one coming? What if this one is different from both Oumuamua and Borisov in ways that leave no doubt about its nature? Let's call this hypothetical object 3I Atlas, and let's imagine that it's been detected by the Asteroid Terrestrial Impact Last Alert System, one of the survey telescopes that scan the sky for potentially hazardous objects. At first, 3I Atlas appears as just another point of light moving against the background stars. Its trajectory marks it as interstellar. It's moving too fast and from the wrong direction to be bound to our solar system. But as our telescopes focus on this new visitor, as we gather more data about its properties and behavior, something extraordinary emerges. The object's brightness doesn't vary randomly like a tumbling asteroid or steadily like a rotating sphere. Instead, it pulses in a regular mathematical pattern. Perhaps it follows the Fibonacci sequence: 1, 1, 2, 3, 5, 8, 13, each pulse duration the sum of the two before it. Or perhaps it transmits prime numbers 2, 3, 5, 7, 11, 13, a pattern that no natural process could create. The implications would be staggering. This wouldn't just be another mysterious object passing through our solar system. This would be a clear, unambiguous signal that someone, somewhere, was trying to communicate. The scientific community would spring into action. Every telescope on Earth and in space would be pointed at 3i Atlas. Radio telescopes would listen for transmissions. Spectroscopes would analyze its composition. Radar would probe its structure. The world would watch as humanity confronted the possibility that we are not alone. But let's slow down for a moment and consider what such a discovery would really mean. Not in terms of dramatic headlines or science fiction scenarios, but in terms of our understanding of ourselves and our place in the universe. The existence of an artificial interstellar object would answer one of humanity's oldest questions. Are we alone? But it would raise 1,000 new ones. Who sent it? When was it launched? Is it a probe, actively gathering information, or a beacon simply announcing its presence? Is it intended specifically for us, or are we just one stop on a grand tour of star systems? The beauty of physical artifacts as a means of interstellar communication is that they solve many of the problems inherent in trying to signal across the vast distances between stars. Radio and light signals weaken with distance, becoming lost in the cosmic background noise. They also require the sender and receiver to be active at the same time, cosmically speaking. A civilization might broadcast for 1,000 years, but if no one is listening during that exact 1,000-year window, the message is lost. But a physical artifact can travel for millions of years, carrying its message faithfully across the eons, waiting patiently to be discovered. Consider the challenge from the perspective of the senders. They know that space is vast and that the chances of their messenger being detected are small, so they would design it to maximize the probability of discovery and recognition. It would need to be large enough to be detected by whatever telescopes the finders might have. It would need to follow a trajectory that takes it through the inner regions of star systems, where planets and observers might be. And most importantly, it would need to be obviously artificial, displaying characteristics that no natural object could have. This is where the regular pulsing of our hypothetical 3i Atlas becomes so significant. Natural objects can vary in brightness. Asteroids tumble, comets outgas, stars pulsate. But they don't count in prime numbers. They don't follow mathematical sequences that have meaning only to minds capable of abstract thought. A signal based on mathematics is universal. Any technological civilization, regardless of their biology, their sensory modalities, their culture, would recognize prime numbers as artificial. It's a way of saying, this is intentional, this is a message, pay attention. But what would the message say? This is where we can let our imagination roam while staying grounded in the realities of physics and information theory. Any message carried by an interstellar artifact would need to be self-contained and self-explanatory. The senders couldn't assume that the finders would share any common language or cultural references. They would have to start from first principles, building up a communication system from scratch. Perhaps the message would begin with basic mathematics and physics, establishing a common ground. The ratio of a circle's circumference to its diameter, the speed of light, the mass of a hydrogen atom, these are the same throughout the universe. From there, the message might progress to more complex concepts. Perhaps it would include a periodic table of elements, showing that the senders understand chemistry as we do. Perhaps it would contain diagrams of their star system, showing the arrangement of planets, maybe even indicating which one they inhabit. The message might also contain information about the senders themselves. Not necessarily what they look like, that might be too difficult to convey without a shared visual language, but perhaps their biochemistry, the molecules that make up their equivalent of DNA, if they have such a thing. They might indicate the temperature range of their planet, the composition of their atmosphere, the length of their day and year. Each piece of information would be a gift, a sharing of the knowledge across the cosmic gulf. But beyond the scientific data, might there be something more? Could an alien civilization encode something of their culture, their history, their values? This is where we enter the realm of pure speculation, but it's beautiful speculation to contemplate as we drift towards sleep. Perhaps they would send music, encoded as mathematical ratios, harmonies that might sound strange to our ears but would represent beauty in another part of the universe. Perhaps they would send images built up pixel by pixel, showing us what their world looks like, what they have achieved, what they dream about. Or perhaps the message would be simpler and more profound. Perhaps it would be nothing more than a statement of existence. We're here. We think. We wonder. You're not alone. In some ways, this simple message might be the most powerful of all. Not a transfer of technology or a solution to our problems, but simply the knowledge that consciousness, intelligence, the capacity to look at the universe and ask, why? These are not unique to Earth, but are woven into the fabric of the cosmos itself. The discovery of such a message would transform our world, but perhaps not in the dramatic, immediate way that science fiction often portrays. There would be no invasion, no sudden leap in technology, no immediate solution to our problems. Instead, there would be a slow, profound shift in how we see ourselves. We would know with certainty that we are part of a community of minds, even if the other members of that community are impossibly distant. Every time we looked at the stars, we would know that somewhere among them, other beings are looking back, wondering about us just as we wonder about them. This knowledge would come with responsibilities. If we are part of a galactic community, even a widely dispersed and non-interacting one, then our actions matter on a cosmic scale. Our survival becomes not just about us, but about maintaining Earth's contribution to the galaxy's diversity of life and thought. Our growth and development become part of a larger story, the story of how intelligence emerges and evolves throughout the universe. We would be cosmic citizens with all the dignity and duty that implies. The discovery might also bring a kind of cosmic humility. If 3i Atlas is an artifact from another civilization, then that civilization must be far older and more advanced than ours. They mastered interstellar travel, even if only for robotic probes, long before we existed. They had the patience and wisdom to send messages that might not be received for millions of years. They thought on scales of time and space that dwarf our current capabilities. We would be the newcomers, the young civilization just beginning to understand its place in a vast and ancient cosmos. But this humility wouldn't be crushing or demoralizing. Instead, it could be inspiring. If they could develop such technology, such wisdom, then perhaps we can too. Their existence would be proof that it's possible to survive the challenges that face young technological civilizations. They made it through whatever filters or challenges lie ahead of us. They found a way to live in harmony with their technology, their planet, perhaps even their stellar neighborhood. Their mere existence would be a message of hope. It can be done. As we contemplate these possibilities, it's worth considering how we would respond to such a discovery. Would we try to send a reply? The distances involved mean that any response would take millions of years to reach its destination. By the time it arrived, the civilization that sent 3i Atlas might have changed beyond recognition, or even ceased to exist. But perhaps that doesn't matter. Perhaps the act of responding is valuable in itself, a way of adding our voice to the cosmic conversation, even if we never hear a reply. We might also be inspired to launch our own messengers, our own artifacts carrying information about Earth and humanity to the stars. We've already done this in a small way with the Voyager probes and their golden records, but discovering that such messaging is actually practiced by other civilizations might motivate us to do more. We could launch hundreds or thousands of small probes, each carrying a message about our world, our species, our dreams and achievements. Most would drift forever in the darkness, but some, eventually, might be found by other young civilizations, giving them the same gift of knowledge and connection that 3i Atlas gave us. The discovery would also likely accelerate our development of space technology. Knowing that interstellar artifacts exist and can be detected would motivate us to look for more. We would build better telescopes, more sensitive detectors, more sophisticated analysis tools. We might develop the capability to intercept and study such objects up close, to actually touch a piece of technology from another star system. Each new discovery would add to our understanding of the galaxy's intelligence, building a picture of the cosmic community we're part of. But perhaps the most profound impact would be psychological and philosophical. For all of human history, we've wondered if we're alone. Religions have grappled with our cosmic significance. Philosophers have debated whether consciousness is unique to Earth or a common feature of the universe. Scientists have searched for evidence of life elsewhere. The discovery of an artificial interstellar artifact would answer these ancient questions, or at least begin to answer them. We would know that we're not alone, that intelligence is not a cosmic accident, but perhaps an inevitable outcome of the universe's evolution. This knowledge would ripple through every aspect of human culture. Art would be transformed by the knowledge that alien aesthetics exist. Science would be energized by the possibility of learning from other civilizations. Philosophy and religion would grapple with the implications of cosmic intelligence. Even our daily lives would be subtly changed by the knowledge that we're part of something larger. Every human achievement, every act of creativity or kindness would be part of Earth's contribution to the galaxy's tapestry of consciousness. As we continue to imagine this scenario, it's important to remember that we're not talking about science fiction, but about a real possibility. The discovery of Oumuamua and Borisov has shown us that interstellar objects do pass through our solar system. The unusual properties of Oumuamua have forced even conservative scientists to consider the possibility that it might be artificial, and our improving technology means that we'll detect more such objects in the coming years and decades. Each one will be an opportunity to learn, to discover, perhaps to find that message we've been hoping for. The search for these objects has become a priority for astronomers around the world. New surveys are being planned that will be able to detect smaller and more distant objects. Advanced telescopes are being built that will be able to study interstellar visitors in unprecedented detail. Some scientists have even proposed missions to intercept future interstellar objects, to send spacecraft to rendezvous with them and study them up close. The technology for such missions is challenging, but not impossible. We could, within a few decades, have the ability to actually examine an object from another star system, to analyze its composition, its structure, perhaps even its information content. The Vera Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, will be particularly important in this search. Starting soon, it will survey the entire visible sky every few nights, detecting objects far fainter than anything we can see today. It's estimated that it might discover dozens or even hundreds of interstellar visitors, giving us a statistical sample that will tell us much about the population of objects drifting through the galaxy. Each discovery will be carefully analyzed for signs of artificiality, for any indication that it might be more than just a wandering space rock. But even as we search for these cosmic messengers, we must remember that the universe operates on its own timescale, not ours. The objects we detect have been traveling for millions of years. Any civilization that launched them did so long before humans existed. They had no knowledge of Earth as it is today, no way of knowing that their message would be received by a species like us. They simply cast their bottles into the cosmic ocean, trusting that somewhere, somewhen, someone would find them and understand. This is the beautiful patience of interstellar communication. It's not a conversation in any human sense, but something far grander. It's a dialogue conducted across deep time, where entire species might evolve and go extinct between question and answer. It requires a kind of faith. Faith that intelligence will persist, that someone will be listening, that the message will eventually find its intended audience. It's an act of cosmic optimism, a belief that the universe tends toward consciousness and communication, despite the vast distances and times involved. As you lie there tonight, perhaps feeling the gentle weight of your blankets, the soft rhythm of your breathing, I invite you to hold this possibility in your mind. Somewhere out there, perhaps already in our solar system, perhaps approaching at this very moment, there might be a message waiting to be discovered. Not a dramatic invasion or an overwhelming first contact, but something far more subtle and profound. A gentle tap on the shoulder of humanity, a whisper across the cosmic darkness saying, "You're not alone." The discovery of such a message wouldn't solve our problems or transform us overnight. We would still face all the challenges that come with being a young technological civilization, but we would face them with new knowledge, new perspective, new hope. We would know that it's possible to survive and thrive, to reach out across the vast distances between stars, to participate in the slow, patient conversation of cosmic intelligence. And that knowledge, that certainty that we're part of something larger, might be exactly what we need to navigate the challenges ahead. Think about what it would mean for humanity's future. Knowing that other civilizations exist and have survived would give us a cosmic perspective on our own problems. The conflicts that divide us, the challenges that seem insurmountable, would be placed in a new context. We would see ourselves as a single species, a single voice in the cosmic chorus, rather than a collection of competing nations and ideologies. The discovery might not unite us immediately, but it would plant the seed of unity, the recognition that our differences are trivial compared to what we share as conscious beings in a vast universe. The discovery would also inspire us to think longer term. If civilizations can send messages across millions of years, then perhaps we should be thinking on similar timescales. Our decisions today would be seen not just in terms of their immediate impact, but in terms of their consequences for the deep future. We would be motivated to preserve our planet, to develop sustainable technologies, to ensure that humanity survives long enough to become a mature cosmic civilization. The message from the stars would be a reminder that the future is vast and full of possibility, but only if we navigate the present wisely. As we drift deeper into contemplation, consider how the discovery of an artificial interstellar artifact would change our relationship with the cosmos. Right now, space is something we explore, something we study, but it's not really something we're part of. We're observers, looking out from our single planet at a universe that seems beautiful but indifferent. But knowing that there are other observers out there, other minds contemplating the same stars, would transform space from a wilderness into a community, albeit one where the neighbors are very far apart and communication takes millions of years. Every time we looked at the night sky, we would see it differently. Those points of light wouldn't just be stars, they would be potential homes to other civilizations. The darkness between the stars wouldn't be empty. It would be full of messages in transit, artifacts drifting on their long journeys, connections being made across impossible distances. The universe would become a living thing, not in a biological sense, but in a conscious sense, aware of itself through the countless minds that have emerged from its physical processes. This shift in perspective might seem subtle, but it would be profound. Humans have always defined themselves in relation to others, to family, to tribe, to nation, to species. Knowing that there are other intelligent species out there would add a new layer to our identity. We would be not just humans, not just earthlings, but citizens of the cosmos, part of the universal community of consciousness. This new identity wouldn't replace our existing ones, but would encompass them, adding a cosmic dimension to what it means to be human. The discovery would also raise profound questions about the nature of intelligence and consciousness. If other beings can create artifacts and send messages, they must have something analogous to what we call mind. But would their consciousness be anything like ours? Would they have emotions, aesthetics, ethics? Would they understand concepts like beauty, truth, love? Or would their minds be so alien that we could barely recognize them as minds at all? The artifact itself might give us clues. The choice to communicate suggests something like curiosity or generosity. The use of mathematics suggests abstract thinking. The patience required for interstellar messaging suggests something like hope or faith. These questions might never be fully answered, but that's part of their beauty. The universe would become not less mysterious, but more so. Each answer would lead to new questions, each discovery to new mysteries. We would be embarked on an infinite journey of discovery, not just about the cosmos, but about the nature of mind, consciousness, and intelligence. The artifact would be not an ending, but a beginning, the first chapter in a book that might never be finished. As we approach the transition to our next contemplation, let's consider one more aspect of this scenario. What if 3i Atlas is not unique? What if, now that we know what to look for, we start finding more artificial artifacts? What if we discover that the galaxy is full of these messages drifting between the stars like seeds on the wind? Each one would add to our understanding, building a picture of the cosmic community we're part of. We might find that civilizations have different styles of communication, different ways of encoding information, different messages to share. The galaxy might be full of diverse voices, each adding to the cosmic conversation. This possibility leads us naturally to our next contemplation. If artificial artifacts exist, if civilizations are sending physical messages between the stars, then we need to look more carefully at the objects we've already discovered. Oumuamua, with its strange properties and unexplained acceleration, deserves a second look. What if we missed something? What if the evidence was there all along, but we weren't ready to see it? As we prepare to revisit that first interstellar visitor, remember that science is not about having all the answers, but about being open to new possibilities, ready to revise our understanding when new evidence emerges. The cosmic ocean is vast and dark, but it's not empty. Objects drift through it, carrying stories from distant shores. Some are natural, shaped by the same forces that formed our own solar system, but others might be bottles with messages inside, cast into the cosmic sea by beings who, like us, looked at the stars and wondered if anyone else was looking back. The discovery of such a message would be the greatest discovery in human history, not because it would give us new technology or solve our problems, but because it would tell us something fundamental about the universe and our place in it. We are not alone. Consciousness is not an accident, and the cosmos is more full of wonder and possibility than we ever dared to imagine. As we continue our journey through these mysteries, drifting deeper into contemplation, we carry with us the image of 3i Atlas, pulsing its mathematical message as it swings through our solar system. It's a beacon in the darkness, a lighthouse on a distant shore telling us that there are safe harbors out there, other islands of consciousness in the cosmic sea. Whether such an object actually exists or remains in the realm of possibility, the mere fact that we can imagine it, that we can search for it, that we can prepare ourselves for its discovery, says something profound about humanity. We are ready to take our place in the cosmic community, ready to listen to messages from the stars, ready to add our own voice to the eternal conversation. The universe is patient. It has been waiting billions of years for conscious beings to emerge and begin to understand it. It can wait a little longer for us to discover whether we're alone or part of a vast community of minds. But we don't have to be patient. We can search, we can wonder, we can prepare ourselves for whatever discoveries await. And as we do, as we scan the skies and analyze the data and debate the possibilities, we're already participating in something cosmic. We're the universe's way of understanding itself, of appreciating its own beauty and mystery. Whether or not we ever receive a message from the stars, we are ourselves a message, a declaration that matter can think, that chemistry can wonder, that physics can dream. The story of 3i Atlas, whether real or hypothetical, is really the story of us, our hopes, our fears, our dreams of connection across the cosmic darkness. It's a story that has no ending because it's still being written. By every astronomer who searches the skies, by every person who looks up at the stars and wonders, by you as you lie there tonight, contemplating these vast mysteries. We're all part of this story, all waiting to see what the next chapter will bring, all hoping that when we finally receive that message from the stars, we'll be ready to understand it and worthy of the cosmic conversation it begins. Now, as we prepare to journey backward in time to revisit Oumuamua, remember that science is a process of constant revision and reconsideration. What seemed like a cigar-shaped rock in 2017 might, in light of new understanding and new possibilities, reveal itself to be something far more extraordinary. The universe doesn't give up its secrets easily, but it does give them up. One discovery at a time, one mystery at a time, one moment of wonder at a time. And sometimes, just sometimes, what we thought was a simple stone turns out to be a key, unlocking doors we didn't even know existed. The ghosts of Oumuamua still haunt the scientific community, whispers of mysteries unsolved and questions unanswered. As we discovered earlier, this first known interstellar visitor to our solar system was unlike anything we had seen before, and the more we learned about it, the stranger it became. Tonight, let's return to those few weeks in late 2017 when humanity had its first confirmed encounter with an object from another star system, and let's examine more closely the enigmas that continue to perplex scientists and fuel speculation about its true nature. When Oumuamua was first detected, astronomers assumed it would be a comet. After all, comets are the most likely objects to be ejected from star systems during planetary formation. They form in the outer regions where gravitational perturbations from giant planets can easily send them flying into interstellar space. A comet would make sense, a dirty snowball from another star carrying ice and dust from an alien solar system. But Oumuamua refused to conform to our expectations. As telescopes around the world focused on this visitor, gathering every photon of light they could, a picture emerged of something far more puzzling. The first surprise was its shape. By measuring how Oumuamua's brightness changed as it tumbled through space, astronomers could deduce its approximate dimensions. The results were extraordinary. This object was at least 6 times longer than it was wide, possibly 10 times, making it look less like a typical asteroid and more like a cosmic cigar, or perhaps a pancake, depending on which model you believed. No asteroid or comet in our solar system has such an extreme shape. The most elongated objects we know of have aspect ratios of maybe 3:1. Oumuamua was in a class by itself. How could such a shape form naturally? Various theories were proposed. Perhaps it was created by tidal forces during a close encounter with a star, stretched like taffy by immense gravitational gradients. Perhaps it was the result of a collision between two objects that created a stream of debris that later reaccumulated into this elongated form. Or perhaps it was shaped by eons of interstellar erosion, cosmic rays and dust impacts gradually wearing away at it, until only this strange needle remained. Each explanation had its proponents, but none was entirely satisfactory. They all required special circumstances, unlikely events, conditions that should be rare rather than producing the very first interstellar object we detected. Then there was its surface. Oumuamua was dark, darker than charcoal, reflecting only about 4% of the sunlight that hit it, but it also had a reddish tinge, similar to some objects in the outer regions of our solar system. This coloration suggested that its surface had been exposed to cosmic rays for a very long time, perhaps millions or billions of years. Cosmic rays break down and transform organic molecules, creating complex carbon compounds that give objects a dark, reddish appearance. This was consistent with a long journey through interstellar space, but it told us nothing about what lay beneath that darkened surface. The real mystery, however, began to emerge as Oumuamua rounded the sun and headed back toward interstellar space. Astronomers tracking its trajectory noticed something unexpected. It wasn't following the path that gravity alone would dictate. There was an additional force acting on it, pushing it away from the sun, causing it to accelerate in a way that couldn't be explained by the gravitational influences of the sun and planets. This non-gravitational acceleration was small but measurable, and it changed everything about how we understood this object. In comets, such acceleration is common and well understood. As a comet approaches the Sun, ice on its surface sublimates, turns directly from solid to gas, creating jets of vapor that push the comet like tiny rocket engines. This outgassing is visible as the comet's coma and tail, spectacular displays that have awed humans throughout history. But here's the crucial point. Oumuamua showed no signs of outgassing. No coma, no tail, no spectroscopic evidence of water, carbon monoxide, carbon dioxide, or any other volatile compounds. It was accelerating like a comet but behaving like an asteroid. This paradox led to increasingly exotic explanations. Perhaps Oumuamua was made of pure hydrogen ice, which would sublimate without leaving visible traces. Hydrogen ice would be transparent to most observations and would evaporate cleanly, providing thrust without a visible tail. But hydrogen ice requires incredibly cold conditions to form, colder than anything in our solar system. It would have to have formed in a giant molecular cloud, the stellar nurseries where stars are born, and even then, it's not clear how a chunk of hydrogen ice could survive the journey through interstellar space without evaporating entirely. Another proposal was that Oumuamua was a dust bunny, a loose aggregation of dust particles held together by weak forces. Such an object would be incredibly porous, perhaps 99% empty space, making it light enough to be pushed by solar radiation pressure. But could such a fragile structure survive the journey between stars? Could it maintain its elongated shape while tumbling through space? The models were uncertain, the physics unclear. It was in this context of mounting mysteries that Avi Loeb, the chair of Harvard's astronomy department, proposed his controversial hypothesis. What if Oumuamua was artificial? What if its strange properties weren't bugs but features, designed characteristics of an alien artifact? The idea wasn't as outlandish as it might seem. A light sail, a spacecraft that uses the pressure of starlight for propulsion, would accelerate in exactly the way Oumuamua did. Its elongated shape would make sense if it was a flat sheet seen edge-on. Its lack of outgassing would be expected for an artificial structure. Loeb's hypothesis sparked fierce debate in the scientific community. Many astronomers criticized it as premature, arguing that we should exhaust all natural explanations before invoking aliens. They pointed out that our knowledge of interstellar objects was limited to exactly one example, hardly enough to say what was normal and what was extraordinary. Others, however, argued that the artificial hypothesis should at least be considered, that dismissing it out of hand was just as unscientific as accepting it without evidence. The debate revealed something profound about how science grapples with anomalies. When faced with something that doesn't fit our existing models, do we stretch those models to accommodate the new observation, or do we consider entirely new possibilities? Oumuamua forced this question upon us in a very public way. Here was an object that challenged our understanding of what interstellar visitors should look like, and we had to decide how to respond. As Oumuamua faded from view, racing back into the darkness between stars, it left us with more questions than answers. Was its shape really as extreme as our measurements suggested, or had we misinterpreted the data? Was its acceleration caused by outgassing we couldn't detect, by radiation pressure on a light sail, or by some physics we don't yet understand? Was it a natural object shaped by processes we haven't imagined, or was it artificial, a piece of alien technology passing through our solar system? These questions aren't just academic exercises. They have profound implications for how we search for and study future interstellar objects. If Oumuamua was artificial, then we need to be looking for signs of technology, not just natural phenomena. We need to be prepared for objects that don't fit our expectations, that challenge our assumptions about what's possible. We need to approach each new discovery with open minds, ready to consider extraordinary possibilities while maintaining scientific rigor. The ghosts of Oumuamua also teach us about the limitations of our current technology. We detected this object only after it had passed closest to the Sun, when it was already on its way out of the solar system. We had just a few weeks to study it before it became too faint to observe. Imagine if we had detected it earlier, if we had had months or years to study it. We could have measured its shape more precisely, analysed its composition in detail, perhaps even sent a spacecraft to intercept it. The next time an interstellar object visits, we need to be ready. This is why projects like the Vera Rubin Observatory are so important. By surveying the sky more frequently and detecting fainter objects, we'll catch interstellar visitors earlier in their journey through our solar system. We'll have more time to study them, to gather the data needed to determine their nature, and if we're very lucky, we might catch one that's moving slowly enough that we could send a mission to intercept it, to study it up close, perhaps even to sample it. Several such missions have been proposed. Project Lyra, for instance, has outlined how we could use existing or near-future technology to catch up with Oumuamua, even though it's now racing away from us at tremendous speed. It would require a complex trajectory, using the sun's gravity to slingshot a spacecraft to incredible velocities, but it's not impossible. Other proposals suggest parking interceptor spacecraft at the Earth-Sun Lagrange points, ready to race toward any interesting interstellar object that appears. These missions would be challenging and expensive, but the scientific payoff could be enormous. Imagine actually touching a piece of another star system, analysing its composition atom by atom, perhaps finding isotope ratios that could only have formed around a different type of star. Or imagine finding structures that couldn't be natural, patterns or materials that indicated artificial origin. Such a discovery would be worth almost any cost, any effort. It would be the discovery of the millennium, perhaps of all human history. But even without such dramatic missions, we can learn much from continued observation. Each new interstellar object we discover adds to our understanding of what's out there, what's normal, and what's extraordinary. If we find that most interstellar objects are like Borisov, clearly natural comets or asteroids, then Oumuamua becomes even more mysterious. But if we find other objects with strange properties, unusual shapes, unexplained accelerations, then we might be seeing evidence of something profound. There's also the intriguing possibility that we've already seen other interstellar objects without recognizing them. Before Oumuamua, astronomers weren't specifically looking for interstellar visitors. How many might have passed through our solar system unnoticed? Some researchers have gone back through archived data, looking for objects with unusual orbits that might have been interstellar. Others have suggested that some long-period comets in our solar system might actually be captured interstellar objects, visitors that arrived with just the right trajectory to be caught by the sun's gravity. The ghosts of Oumuamua also haunt our imagination, inspiring us to think about what else might be out there. If one artificial object passed through our solar system, might there be others? Could there be a whole population of alien artifacts drifting through the galaxy, each one a message or a probe or a piece of cosmic archaeology? Some scientists have suggested that the galaxy might be full of such objects. A vast library of information waiting to be discovered by emerging civilizations like ours. This idea, sometimes called the lurker hypothesis, suggests that alien probes might even be present in our solar system right now, watching us, waiting for us to reach some threshold of development before revealing themselves. They might be in the asteroid belt, camouflaged among natural rocks. They might be at the gravitationally stable Lagrange points, perfectly positioned to observe Earth. They might be anywhere, patient and silent, waiting for the right moment to make contact. While this might sound like science fiction, it's being taken seriously enough that some astronomers are actively looking for such objects. They're searching for asteroids with unusual compositions or behaviors, for objects at Lagrange points that shouldn't be there naturally, for any sign that we're not alone in our own solar system. So far, they found nothing definitive, but the search has barely begun. The legacy of Oumuamua extends beyond science into philosophy and culture. This object forced us to confront the possibility that we might have already had our first contact with alien technology, even if we didn't recognize it at the time. It reminded us that the universe is full of surprises, that our models and expectations are constantly being challenged by new discoveries. It taught us humility, the humility to admit that we don't understand everything, that there are mysteries that might take generations to solve. Oumuamua also changed how we think about interstellar communication. Before its discovery, most SETI efforts focused on radio signals or laser pulses, electromagnetic waves traveling at the speed of light. But Oumuamua showed us that physical objects can also travel between stars, carrying information in a different form. If civilizations are sending probes rather than signals, we need to adjust our search strategies accordingly. This shift in thinking has led to new proposals for both searching and messaging. Some scientists suggest we should be looking for artificial satellites around other stars, megastructures that might be visible in transit data. Others propose that we should launch our own interstellar probes, not just to explore but to announce our presence to anyone who might find them. These projects would take decades or centuries to bear fruit, but they represent a long-term investment in humanity's cosmic future. As we reflect on Oumuamua's visit, it's worth considering what it means that we noticed it at all. For all of human history until 2017, interstellar objects passed through our solar system undetected. We lacked the technology to see them, the knowledge to recognize them, the framework to understand them, but now we can. We've crossed a threshold, developed the capability to detect and study visitors from other stars. This is a profound achievement, a marker of our growth as a technological civilization. Think about what this means from a cosmic perspective. If other civilizations exist, they might judge a species' development by various milestones. The use of tools, the development of language, the discovery of science. These are all important steps. But the ability to detect interstellar objects might be particularly significant. It shows that a civilization has developed sophisticated technology, that it's looking outward rather than just inward, that it's ready to engage with the cosmos on a larger scale. Perhaps this is why Oumuamua appeared when it did, not by chance but as a test, a check to see if humanity had reached this crucial milestone. This is speculation, of course, but it's speculation grounded in the very real mystery of Oumuamua. This object appeared at an interesting moment in human history, just as we developed the ability to detect it. It displayed properties that challenged our understanding, forced us to think in new ways, sparked debates that continue to this day. Whether natural or artificial, Oumuamua was a gift, a cosmic wake-up call that reminded us that we're part of a larger universe, that surprises await us among the stars. The ghosts of Oumuamua also remind us of the importance of being prepared. We had only weeks to study this object, and much of that time was spent just figuring out what we were looking at. Next time, we need to be ready. We need protocols for quickly identifying and studying interstellar objects. We need spacecraft ready to launch on intercept missions. We need international cooperation to ensure that all of humanity's observational resources can be brought to bear. The next Oumuamua might be even more mysterious, even more clearly artificial, and we need to be prepared to make the most of the opportunity. As we move forward, the mystery of Oumuamua remains unsolved. Was it a bizarre natural object shaped by processes we don't understand? Was it a light sail, a piece of alien technology drifting through the cosmos? Was it something else, entirely? Something we don't even have a category for? We may never know for certain. Oumuamua is gone, racing into the darkness, carrying its secrets with it. But its legacy remains, the questions it raised, the possibilities it opened, the reminder that the universe is stranger and more wonderful than we imagined. In a sense, Oumuamua was perfect in its ambiguity. If it had been clearly natural like Borisov, it would have been interesting but not transformative. If it had been clearly artificial, with obvious signs of technology, it might have been too much too soon, a shock that humanity wasn't ready for. But by being mysterious, by defying easy categorization, Oumuamua gave us exactly what we needed, a gentle push toward considering new possibilities, a reason to look more carefully at the cosmos, inspiration to develop better tools and techniques for studying the unknown. The ghosts of Oumuamua will haunt astronomy for generations. Every new interstellar object will be compared to it. Every strange asteroid or comet will raise the question, could this be another Oumuamua? Every improvement in our detection and analysis capabilities will be partly motivated by the desire to better understand objects like Oumuamua. It has become a benchmark, a reference point, a reminder of how much we still have to learn, and perhaps that's its greatest gift. Oumuamua reminded us that we're still at the beginning of our journey of cosmic discovery. We've learned so much in the past century. The size of the universe, the nature of stars and galaxies, the existence of exoplanets. But Oumuamua showed us that there are still fundamental mysteries waiting to be uncovered, still surprises that can challenge everything we think we know. It renewed our sense of wonder, our excitement about exploration, our hope that the universe might be even more interesting than we dared to dream. As you lie there tonight, perhaps drifting towards sleep, think about Oumuamua tumbling through the darkness somewhere out there between the stars. It's been travelling for millions of years and will continue for millions more. Long after humanity has changed beyond recognition, or perhaps ceased to exist, Oumuamua will still be out there, carrying whatever secrets it holds. But for a brief moment in 2017, our paths crossed. We saw it, we wondered about it, we were changed by it, and in that moment, we became part of its story, just as it became part of ours. The universe is full of such fleeting connections, brief encounters between objects and civilizations separated by vast distances and times. Most go unnoticed, ships passing in the cosmic night. But occasionally, rarely, preciously, we notice. We see the visitor, we recognize its significance, we're touched by the mystery and wonder of it all. These moments are gifts, reminders that we're not isolated on our small world, but part of a vast interconnected cosmos where anything is possible and mysteries await around every corner. Oumuamua was our first confirmed interstellar visitor, but it won't be our last. Others are coming, perhaps already here, waiting to be discovered. Each one will tell us something new about the galaxy, about the processes that shape star systems, about the possibilities for life and intelligence beyond Earth, and perhaps one of them will be unambiguously artificial, carrying a message that ends the great silence and begins a new chapter in the human story. Until then, we watch, we wonder, and we remember the ghosts of Oumuamua, our first glimpse of the interstellar ocean that surrounds us. Now, as we prepare to contemplate what kind of message an artificial object might carry, let's consider the profound challenge of communication across not just space, but across potentially vast differences in biology, psychology, and culture. If Oumuamua or something like it is artificial, if it carries information intended for whoever might find it, how would that message be structured? How do you communicate with beings you know nothing about, who might perceive the universe in ways you can't imagine, who might not even have the same sense as you do? This is the puzzle we'll explore next, the architecture of a truly universal message. The architecture of a message meant to cross the vast gulfs between stars, between species, between minds that might share nothing in common except the fact of their existence, presents one of the most fascinating puzzles in all of science and philosophy. As we drift deeper into our contemplation tonight, let's explore what such a message might look like, how it might be constructed, and what it might contain. Imagine for a moment that you are tasked with creating a message that will be launched into the cosmos, a message that might not be found for millions of years by beings whose nature you cannot predict. How would you even begin? This is not merely a thought experiment. Human beings have already attempted this challenge several times. The Pioneer plaques, the Voyager golden records, the Arecibo message, each represents our attempt to speak to the cosmos, to introduce ourselves to whoever might be listening. But these messages were created with certain assumptions about the receivers, that they would have eyes to see images, ears to hear sounds, an understanding of physics similar to ours. What if these assumptions are wrong? What if the beings who find our messages perceive the universe in ways we cannot imagine? The challenge becomes even more complex when we consider that a message carried by an interstellar object like our hypothetical 3-eye atlas would need to be completely self-contained. There can be no back and forth, no clarification, no opportunity to correct misunderstandings. The message must teach its own language, provide its own context, build understanding from the ground up. It's like trying to write a book that teaches someone to read while they're reading it. Except the reader might not even have eyes, might not even understand what a book is. The solution, most scientists agree, lies in mathematics and physics. These are truly universal languages, the same everywhere in the cosmos. The ratio of a circle's circumference to its diameter is pi, whether you're on Earth, in the Andromeda Galaxy, or in a universe parallel to our own. The hydrogen atom has the same properties everywhere. The speed of light in vacuum is constant throughout the cosmos. These unchanging facts provide a foundation upon which communication can be built. So perhaps our message begins with the simplest mathematical concepts, a series of pulses, 1, then 2, then 3. Basic counting, the foundation of all mathematics. Then perhaps prime numbers, 2, 3, 5, 7, 11, 13. These numbers are special, divisible only by themselves and 1, and any technological civilization would recognize them as such. No natural process creates prime number sequences. They're a clear sign of intelligence, of a mind that understands abstract mathematical concepts. From there, the message might progress to more complex mathematics. The Pythagorean theorem, perhaps, demonstrating an understanding of geometry. The Fibonacci sequence, showing knowledge of recursive relationships. Pi and E, the fundamental constants that appear throughout mathematics and physics. Each concept would build on the previous ones, creating a ladder of understanding that the receivers could climb step by step until they grasped the mathematical framework the senders were using. But mathematics alone cannot convey everything. At some point, the message must bridge from abstract numbers to physical reality. This might be done through physics constants and relationships. The message might encode the mass ratio of the proton to the electron, a dimensionless number that's the same everywhere. It might describe the energy levels of the hydrogen atom, the simplest atom in the universe. It might include the fine structure constant, that mysterious number that governs the strength of electromagnetic interactions. These physical constants serve two purposes. First, they demonstrate that the senders understand the physical universe, that they're not just mathematicians but scientists. Second, they provide a calibration system. By comparing the values in the message to their own measurements, the receivers can understand the units being used, the precision of the measurements, perhaps even something about the technology used to make them. With mathematics and physics established, the message could move on to chemistry. The periodic table of elements would be universal. Hydrogen is hydrogen everywhere. Carbon is carbon. Iron is iron. The message might show how atoms combine to form molecules, perhaps focusing on molecules that are important for life as we know it. Water, ammonia, methane, simple molecules that are common throughout the universe. Then perhaps amino acids, the building blocks of proteins, showing that the senders understand organic chemistry. This is where the message might begin to reveal something about the senders themselves. If they include information about DNA or its equivalent, they're telling us about their biochemistry. The specific molecules they emphasize might reveal what kind of environment they evolved in. Do they focus on water-based chemistry, suggesting a liquid water habitat like Earth? Or do they emphasize ammonia or methane, suggesting a much colder environment? Each choice in the message would be a clue about the nature of its creators. But how would such information be encoded in a physical object? This is where the architecture becomes truly ingenious. The object itself might be the message. Its composition could encode information, unusual isotope ratios that spell out mathematical sequences, layers of different materials that represent different concepts, structures at the molecular level that carry data like a three-dimensional book. The object might be designed to reveal its information gradually, as the finder's technology improves. Surface features visible to telescopes, internal structures revealed by radar, molecular information accessible only through direct sampling. The message might also be dynamic. As our hypothetical 3-eye atlas tumbles through space, its changing brightness could encode information. Not random tumbling, but a carefully choreographed dance, each rotation revealing new data. The pattern might start simple, basic counting, prime numbers, then become increasingly complex as the receivers demonstrate their ability to decode it. It's a test and a teaching tool combined, revealing its secrets only to those ready to understand them. Consider the elegance of this approach. The message doesn't assume any particular sensory modality. Whether the receivers see with eyes, echolocate like bats, or perceive through some sense we don't have, they can detect the object's changing brightness or radio emissions or gravitational effects. The mathematical patterns would be recognizable regardless of how they're perceived. It's truly universal communication, transcending the limitations of biology and culture. The message might also include something like a Rosetta Stone, the same information encoded in multiple ways. Mathematical sequences expressed as brightness variations, radio pulses, and physical structures. This redundancy serves multiple purposes. It increases the chances that the message will be understood, provides error checking, and demonstrates the sender's sophistication. It shows that they have thought carefully about the challenge of interstellar communication and have tried to make their message as accessible as possible. But beyond the scientific data, could such a message convey something about the culture, the hopes, the dreams of its creators? This is where we enter more speculative territory, but it's beautiful speculation. Perhaps the mathematical sequences chosen have aesthetic as well as scientific significance to the senders. Perhaps the way information is organized reveals something about how they think, how they categorize knowledge. Perhaps there are patterns within patterns, layers of meaning that become apparent only after deep study. Music, some have suggested, might be a universal language, not the specific sounds of music which depend on particular hearing apparatus, but the mathematical relationships that underlie harmony and rhythm. Ratios like 2-1, an octave, 3-2, a perfect fifth, 4.3, a perfect fourth, might have aesthetic significance to any beings capable of perceiving patterns. The message might include these ratios, not as scientific data but as an attempt to share something beautiful, to make an aesthetic connection across the cosmos. Images present a particular challenge. How do you convey visual information to beings that might not have eyes? One approach is to build up from first principles. Start with simple geometric shapes, a circle, a square, a triangle. Then combine them to create more complex forms. Use a grid system, with each cell either on or off, to create bitmap images. Start with simple patterns, then gradually increase complexity until you're conveying real information. Star maps, diagrams of solar systems, perhaps even representations of the senders themselves. But even if the receivers can decode such images, will they understand them? A picture of a spiral galaxy might be meaningless to beings who have never seen one. A diagram of an atom might be incomprehensible to those who visualize atomic structure differently. This is why the message must be self-teaching, providing not just information but the context needed to understand it. Each concept must build on previous ones, creating a chain of understanding that leads from simple mathematics to complex ideas about the universe and our place in it. The message might also include what we might call metadata, information about the message itself. When was it sent? How long did it travel? What was the position of the sender's star when it was launched? This temporal and spatial information would help the receivers understand the context of the message, perhaps even identify the star system it came from. It would turn the message from an abstract communication into a historical artifact, a specific attempt by a specific civilization to reach out across the cosmos. timestamps would be particularly challenging to convey. How do you express time to beings who might measure it completely differently? One approach is to use universal physical processes, the vibration frequency of a cesium atom, the half-life of certain radioactive isotopes, the period of pulsar rotation. These provide universal clocks that any technological civilization could understand. The message might define its time unit in terms of these physical processes, then use that unit to convey when it was sent and how long it was expected to travel. The architecture of the message might also include what engineers call graceful degradation. Even if parts of the message are damaged or misunderstood, other parts should still be comprehensible. The most important information might be repeated multiple times in multiple formats. Basic concepts would be standalone, not dependent on understanding other parts of the message. This robustness would be crucial for a message that might travel for millions of years through the harsh environment of interstellar space. There's also the fascinating possibility that the message might be interactive in some way. Not in the sense of two-way communication, which is impossible over interstellar distances, but in the sense that it responds to investigation. Perhaps certain parts of the message only become accessible when the receivers demonstrate they've understood earlier parts. Perhaps the object changes its behavior when probed with certain frequencies of electromagnetic radiation. Perhaps it's designed to reward curiosity and careful study with ever deeper layers of information. This interactivity could serve as a kind of intelligence test. Only civilizations that have reached a certain level of scientific and technological development would be able to access the full message. This isn't exclusionary, but protective. The advanced information in the message might be dangerous if misunderstood or misused. By requiring sophisticated understanding to access it, the senders ensure that only civilizations mature enough to handle the information responsibly will receive it. The message might also include negative information, things the senders don't know, questions they're asking, mysteries they haven't solved. This humility would be profound. It would show that the senders, however advanced, don't have all the answers. They're fellow seekers, fellow wanderers, reaching out not from a position of omniscience, but from a shared curiosity about the universe. The message becomes not a lecture but an invitation to a conversation, even if that conversation takes millions of years per exchange. Consider what it would mean to receive such a message. Not just the scientific information, valuable as that would be, but the knowledge that someone, somewhere, thought we were worth talking to. They spent resources, perhaps vast resources, to create and launch this message. They did so knowing they would never receive a reply, never know if their message was received. It's an act of cosmic faith, a belief that intelligence and curiosity are precious enough to nurture wherever they're found. The architecture of such a message also tells us something about the nature of intelligence itself. Any beings capable of creating such a message must have certain cognitive abilities. They must be able to think abstractly, to understand that symbols can represent things. They must be able to plan for the far future, to work on projects whose payoff they'll never see. They must have some concept of other minds, the ability to imagine beings different from themselves. These cognitive requirements might be universal for technological civilizations, suggesting that however different aliens might be in their biology, they might be surprisingly similar in their psychology. The message might also reveal something about the sender's values. The choice to communicate at all suggests they value connection, knowledge sharing, the growth of cosmic intelligence. The effort required to create and launch an interstellar message suggests they think long-term, that they care about the future even beyond their own existence. The careful construction of the message, making it as accessible as possible, suggests a kind of cosmic altruism, a desire to help younger civilizations develop. But there's also the possibility that the message might contain warnings, not threats, but information about dangers the senders have encountered and survived. Perhaps there are certain technologies that are inevitably discovered but potentially catastrophic if mishandled. Perhaps there are natural cosmic phenomena that pose threats to developing civilizations. The message might be partly an attempt to help younger civilizations navigate these dangers to benefit from the hard-won wisdom of those who came before. This brings us to one of the most profound questions about such messages. Should they include advanced technological information? The senders might have technologies that could solve many of our problems: clean energy, faster-than-light communication, medical breakthroughs. But sharing such information with a younger civilization could be dangerous. We might not be ready for it, might use it destructively, might have our natural development disrupted. The architecture of the message must grapple with this dilemma, perhaps including advanced information, but encoding it in ways that require significant scientific maturity to decode. The message might also be designed to grow with the receiving civilization. As our understanding increases, as our technology improves, we might discover new layers of information that were always there but that we couldn't perceive before. The message becomes a long-term companion to our development, revealing new secrets as we become ready to understand them. It's like a teacher that adapts to the student's level, always challenging but never overwhelming. Think about the psychological impact of such a message. Knowing that it contains information we can't yet understand would be a powerful motivator for scientific and technological development. It would give us concrete goals: decode this section, understand that pattern, access those data layers. The message becomes not just a communication but a curriculum, guiding our development in directions the senders think are important or beneficial. The architecture might also include what we could call existential information, insights about the nature of consciousness, intelligence, the meaning of existence. These would be the hardest concepts to convey, requiring not just scientific understanding but philosophical sophistication. How do you express ideas about consciousness to beings whose consciousness might be fundamentally different from yours? How do you share insights about the meaning of existence when meaning itself might be culturally dependent? Perhaps such concepts would be conveyed not directly, but through the structure of the message itself, the choice to communicate, the effort expended, the care taken in construction. These themselves express a philosophy, a worldview that values intelligence, curiosity, and connection. The medium becomes part of the message, teaching by example rather than explanation. As we contemplate the architecture of such a message, we're really contemplating the nature of communication itself. What can be shared between minds that might share nothing except the fact of being minds? What is truly universal versus what is culturally or biologically specific? These questions aren't just relevant for interstellar communication. They touch on fundamental issues in philosophy of mind, linguistics, and cognitive science. The message might also include something like art, patterns or structures that have no informational content but are simply beautiful by some universal aesthetic standard. This would be the most speculative part of the message, based on the hope that there might be some commonality in what different intelligences find beautiful. Perhaps certain mathematical ratios, certain symmetries, certain patterns are inherently pleasing to any mind capable of perceiving pattern and structure. The inclusion of such aesthetic elements would say something profound about the senders. It would show that they value beauty as well as truth, that they see the universe not just as something to understand but as something to appreciate. It would be an invitation to share not just knowledge but wonder, not just facts but feelings about those facts. As our hypothetical three-eye atlas tumbles through our solar system, pulsing its mathematical messages, it carries all of these layers of meaning. Surface observations reveal basic patterns that announce its artificial nature. Deeper investigation uncovers scientific data about another star system, another world, perhaps another form of life. Still deeper study might reveal cultural information, aesthetic choices, philosophical insights. And perhaps, at the deepest level, there's something we won't understand for generations. A gift for our descendants, a mystery for future humanity to unravel. The architecture of such a message is itself a work of art, a careful balance of accessibility and depth, simplicity and complexity, universality and specificity. It must work across vast differences in biology, psychology, and culture, yet still convey meaningful information. It must be robust enough to survive millions of years in interstellar space, yet sophisticated enough to carry complex data. It must be obvious enough to be recognized as artificial, yet subtle enough to reward deep study. Creating such a message would be one of the greatest challenges a civilization could undertake. It would require not just scientific and technological sophistication, but deep wisdom about the nature of mind, communication, and understanding. The civilization that could create such a message would have to have solved problems we're only beginning to recognize, achieved insights we can barely imagine. And yet, the fact that we can imagine such a message, that we can think about how to create one ourselves, suggests that we're beginning to develop this capability. The SETI researchers who designed detection algorithms, the scientists who created the Voyager Golden Records, the philosophers who ponder the nature of universal communication, all are contributing to our understanding of how to architect messages for the cosmos. Perhaps one day we'll launch our own 3i Atlas, our own messenger to the stars. It will carry information about Earth, about humanity, about our journey from primordial soup to spacefaring civilization. It will be our contribution to the galactic library, our message in a bottle cast into the cosmic ocean. And maybe, millions of years from now, it will tumble through some alien solar system, where curious minds will detect it, study it, and wonder about the beings who sent it, just as we wonder about the possible creators of the mysterious objects passing through our own system. The architecture of interstellar messages is ultimately about connection, the deep, perhaps universal desire of conscious beings to know they're not alone, to share their knowledge and wonder with others who can appreciate it. It's about transcending the vast distances and differences that separate us, finding common ground in mathematics, physics, and perhaps even beauty. It's about participating in a conversation that spans millions of years and billions of miles, a conversation that might be the most important one in the universe, the conversation between minds about what it means to be a mind in a cosmos that seems designed to keep us apart, yet gives us the ability to reach toward each other across the darkness. As we prepare to contemplate what such a discovery might mean for humanity's future, for our understanding of our place in the cosmos, remember that every scientific paper about interstellar objects, every philosophical essay about communication, every science fiction story about first contact is part of our preparation. We're training ourselves to recognize and understand messages from the cosmos, developing the conceptual tools we'll need if and when such a message arrives. The architecture of interstellar messages isn't just about how they encode information. It's about how we prepare ourselves to receive and understand that information, how we architect our own minds to be ready for contact with the truly alien. The possibility that we might not be alone in the universe, that intelligence might be reaching out to us through carefully crafted messages carried by interstellar objects, invites us to reconsider everything about our place in the cosmos. As we continue our journey tonight, drifting deeper into these profound mysteries, let's explore what it might mean for humanity if we discovered that 3i Atlas, or something like it, was indeed carrying a message from another civilization. How would this knowledge transform our understanding of ourselves, our future, and our responsibilities as a conscious species in what might be a conscious universe? Imagine waking up tomorrow to headlines announcing that scientists have confirmed the artificial nature of an interstellar object, that we have received unambiguous evidence of intelligence beyond Earth. The immediate reaction would likely be a mixture of excitement, fear, wonder, and confusion. But as the initial shock wore off, as humanity began to process this momentous discovery, deeper and more profound changes would begin to ripple through our collective consciousness. We would need to create a new map of home, one that includes not just Earth and our solar system, but our place in a galaxy that we now know contains other minds, other perspectives, other ways of being conscious in the cosmos. The first and perhaps most fundamental shift would be in our sense of identity. Throughout human history, we've defined ourselves in relation to others, our family, our tribe, our nation, our species. But we've always been the only known intelligent species, the sole bearers of consciousness in an otherwise unconscious universe. The discovery of alien intelligence would add a new layer to our identity. We would become not just humans, not just earthlings, but representatives of Earth's intelligence in a cosmic community. This new identity wouldn't replace our existing ones, but would encompass them, adding a cosmic dimension to what it means to be human. This shift in identity would likely have profound psychological effects. Many people report a sense of cosmic loneliness when contemplating the vast, seemingly empty universe. This existential isolation has been a theme in philosophy, literature, and art for centuries. But knowing that we're not alone, that somewhere among the stars other beings are looking back, would fundamentally alter this experience. The universe would transform from a vast, indifferent wilderness into a community, albeit one where the neighbours are very far apart and communication takes millions of years. The darkness between the stars would no longer be empty but full of potential, full of others who share our capacity for wonder and questioning. Consider how this might affect our approach to the great challenges facing humanity: climate change, nuclear weapons, artificial intelligence, pandemic disease. These existential risks would be seen in a new light. We would know that it's possible for technological civilizations to survive these challenges, because at least one has done so and reached the point of sending interstellar messages. This wouldn't guarantee our survival, but it would provide hope, evidence that the great filters that might destroy civilizations can be navigated successfully. The message from the stars would be, in part, a message of hope. It can be done, you can survive and thrive. The discovery would also likely accelerate our technological development, but perhaps not in the way you might expect. While the message might contain some scientific information we don't yet know, its greater impact might be in showing us what's possible. Knowing that interstellar travel, even for robotic probes, is achievable would inspire us to pursue it ourselves. Seeing evidence of technologies we haven't imagined would expand our sense of what's possible, breaking us out of conceptual limitations we didn't even know we had. The message would be like a light on the horizon, showing us a direction to walk even if it doesn't provide a detailed map. Our scientific priorities would almost certainly shift. The search for and study of interstellar objects would become a major focus. We would develop new telescopes, new detection methods, new analytical techniques, all aimed at finding and understanding these cosmic messengers. The discovery of one artificial object would suggest there might be others, perhaps many others. The galaxy might be full of these messages, each from a different civilization, each with different information to share. We would be like archaeologists who have just discovered that the desert they're exploring is full of buried cities, each one a treasure trove of information about the past. The discovery would also transform our approach to space exploration. Knowing that there are other civilizations out there, even if they're impossibly distant, would provide a powerful motivation for expanding beyond Earth. We would want to ensure our survival as a species, to spread to other worlds so that no single catastrophe could eliminate Earth's contribution to galactic intelligence. We would want to develop the technologies that would eventually allow us to send our own messages, to add our voice to the cosmic conversation. Space exploration would shift from being primarily about science and resources to being about securing humanity's cosmic future. But perhaps the most profound impact would be on our philosophy and worldview. For centuries, humans have debated whether consciousness is unique to Earth or a common feature of the universe. The discovery of alien intelligence would decisively answer this question. We would know that the universe naturally gives rise to consciousness. That matter can organize itself into patterns complex enough to be aware, to think, to wonder about its own existence. This would have implications for everything from religion to artificial intelligence research, from environmental ethics to the search for meaning in existence. Different religions and philosophical traditions would respond to this discovery in different ways. Some might see it as confirmation of their beliefs about the abundance of life and consciousness in creation. Others might need to significantly revise their doctrines to accommodate the existence of non-human intelligence. New philosophical and spiritual movements would likely emerge, attempting to integrate this cosmic perspective into human meaning-making. The discovery wouldn't end religious and philosophical questioning, but would add new dimensions to these eternal human pursuits. The discovery might also affect how we think about consciousness itself. If alien minds exist, they might be profoundly different from ours. They might perceive time differently, process information differently, experience emotions we don't have, or lack ones we consider fundamental. Understanding their message might require us to expand our concept of what minds can be, what consciousness can look like. This could have profound implications for our development of artificial intelligence. If consciousness can take radically different forms, then perhaps the AIs we create don't need to mirror human consciousness, but could be something genuinely new and different. Our relationship with Earth itself might change. Knowing that we're representatives of our planet in a cosmic community might make us more protective of Earth's unique biosphere. Every species on Earth, from the simplest bacteria to the most complex mammals, will be seen as part of Earth's contribution to galactic diversity. Biodiversity conservation would become not just an environmental issue but a cosmic responsibility. We would be the guardians of one of the galaxy's experiments in life and consciousness, responsible for preserving and nurturing it for the future. The discovery would also likely inspire a renaissance in human creativity. Artists would have new themes to explore, new perspectives to consider. Writers would imagine what alien civilizations might be like, how contact might unfold, what the future might hold. Musicians might experiment with the mathematical patterns in the message, looking for universal harmonies. The knowledge that we're not alone would be a wellspring of inspiration, driving human creativity in directions we can't yet imagine. Education would need to evolve to prepare young people for this new reality. Children would grow up knowing that they're citizens not just of a nation, or even a planet, but of a galaxy with multiple intelligent species. The curriculum would need to include not just Earth history but cosmic history, not just human cultures but speculation about alien cultures. Critical thinking skills would become even more important as we grapple with information from sources we don't fully understand. We would need to raise a generation comfortable with uncertainty, capable of thinking on cosmic scales, prepared to participate in humanity's cosmic future. The discovery might also change how we think about time and patience. Interstellar communication, if it happens at all, would occur on timescales that dwarf human lifespans. A message sent to the star system that 3i Atlas came from might not receive a reply for millions of years. This would require us to think and plan on geological or even astronomical timescales. Projects might be initiated that won't be completed for thousands of generations. We would need to develop new institutions, new ways of maintaining continuity across vast spans of time. Humanity would need to mature into a species capable of truly long-term thinking. International cooperation would likely become more important and more achievable. The discovery that we're not alone in the universe might help us overcome the tribal divisions that have plagued humanity throughout history. Faced with the reality of alien intelligence, the differences between human nations, cultures, and ethnic groups might seem less significant. We might finally achieve the unity that has eluded us, not through conquest or coercion, but through the recognition of our common humanity in the face of the cosmic other. The message from the stars might do what no earthly force has been able to do, unite humanity as a single species with a common destiny. But this unity wouldn't mean homogenization. In fact, human diversity might be valued more than ever. If we're going to communicate with alien civilizations, if we're going to understand minds that might be radically different from ours, we'll need all the different perspectives and ways of thinking that human diversity provides. Each culture, each language, each way of seeing the world might offer unique insights into the alien message. diversity would be recognized not as a weakness to be overcome, but as a strength to be celebrated and preserved. The discovery would also raise profound ethical questions. If there are other intelligent beings in the universe, do we have obligations to them? Should we consider their interest when making decisions that might affect them, even if they're light years away? If we develop technologies that could be dangerous on a galactic scale, do we have a responsibility to ensure they're not misused? These questions might seem abstract now, but they would become very real if we knew for certain that other civilizations exist. There would also be practical questions about how to manage the discovery. Who speaks for Earth in responding to an alien message? How do we ensure that the information is shared fairly with all of humanity? How do we prevent the discovery from being exploited for national or commercial advantage? These questions would require new forms of international cooperation, perhaps even new global institutions dedicated to managing humanity's cosmic relationships. The discovery might also inspire us to send our own messages more actively. Knowing that at least one civilization has successfully sent an interstellar message would encourage us to do the same. We might launch hundreds or thousands of small probes, each carrying information about Earth and humanity. These wouldn't be aimed at any particular star, but would be sent in all directions, maximizing the chances that one would eventually be found. We would be adding our voice to what might be a galaxy-wide conversation, even if we never hear a reply. The psychological impact on individuals would vary greatly. Some would find the discovery exhilarating, a confirmation of their hopes and dreams about the universe. Others might find it frightening, a challenge to their worldview and sense of human specialness. Many would likely experience a mix of emotions, cycling through wonder, fear, excitement, and confusion as they process this new reality. Mental health support systems would need to be prepared for the existential challenges the discovery might trigger. Children who grow up after the discovery would have a fundamentally different relationship with the cosmos than previous generations. For them, a universe with multiple intelligent species would be normal, taken for granted. They might be less Earth-centric in their thinking, more naturally cosmic in their perspective. They might dream not just of traveling to other countries, but to other star systems, not just of meeting people from different cultures, but beings from different worlds. The discovery would shape their imagination and aspirations in ways we can barely predict. The discovery would also affect our relationship with technology. Knowing that at least one civilization has developed the technology to send interstellar messages would change how we think about technological development. Technology would be seen not just as a tool for solving problems, but as a ladder to cosmic citizenship. Each advancement would be evaluated not just for its immediate benefits, but for how it moves us closer to being able to participate fully in galactic civilization. The development of AI, for instance, might be seen as a necessary step toward the kind of intelligence augmentation that interstellar civilization might require. Our approach to SETI would be transformed. No longer would it be a speculative search for something that might not exist. It would be a focused effort to find more messages, to detect other civilizations, to map the intelligence of our galaxy. Resources that are currently limited would likely be expanded dramatically. New detection methods would be developed. The search would become one of humanity's grand projects, comparable to the Human Genome Project or the Apollo program, but extending over centuries or millennia. The discovery might also change how we think about death and mortality. Knowing that intelligence persists in the universe, that consciousness is not unique to Earth, might provide a kind of cosmic comfort. Individual death would still be tragic, but the death of human civilization would be even more so because it would mean the loss of Earth's unique perspective in the cosmic conversation. This might inspire us to take existential risks more seriously, to invest more in ensuring our long-term survival, to think of ourselves as temporary custodians of something precious and irreplaceable. As we contemplate these possibilities, it's worth remembering that the impact of such a discovery would unfold over time. The immediate reaction would be just the beginning. As we study the message more deeply, as we discovered new layers of information, as we integrated this knowledge into our science and culture, new implications would continue to emerge. The discovery would be not a single event, but an ongoing process of revelation and understanding that might continue for centuries. The discovery would also likely inspire a new relationship with the night sky. Every clear night would be an opportunity to look up and wonder which stars have planets with life, which points of light represent home to other conscious beings. The stars would no longer be distant suns, but potential homes to others like us. Not like us in form, perhaps, but like us in their capacity to wonder at the universe. The night sky would become a reminder of our cosmic connections, our place in the community of galactic intelligence. Our literature and mythology would be enriched with new stories. Just as ancient humans created myths about the stars and planets, we would create new myths about our cosmic neighbors. These stories would help us process the emotional and philosophical implications of the discovery, giving us narratives through which to understand our new reality. Science fiction would no longer be purely speculative, but would be grounded in the knowledge that alien intelligence actually exists. It might become a more serious genre, a way of preparing for possibilities that we know are real. The discovery might also inspire us to take better care of ourselves as a species. Knowing that we're Earth's representatives in a cosmic community might motivate us to be better, to overcome our destructive tendencies, to develop wisdom commensurate with our growing power. We might feel a sense of cosmic embarrassment about our wars, our environmental destruction, our failures to care for all members of our species. This cosmic perspective might provide the motivation we need to finally mature as a species, to become worthy of membership in a galactic community. As we near the end of our contemplation of what this discovery might mean for humanity, it's important to acknowledge that much of what we've discussed is speculation. We don't know how humanity would actually react to the discovery of alien intelligence. We don't know what forms that intelligence might take or what messages it might send. But by imagining these possibilities, by thinking through the implications, we prepare ourselves mentally and emotionally for what might be the most important discovery in human history. The map of home that we would need to create after such a discovery would be vastly larger than any we've imagined before. It would encompass not just our planet, not just our solar system, but our entire galaxy, and perhaps beyond. It would show us as one small but precious part of a vast tapestry of consciousness, connected to other intelligences by shared wonder at the cosmos we all inhabit. This new map wouldn't diminish us, but would dignify us, showing that we're part of something magnificent, something that transcends the boundaries of space and time. As you lie there tonight, perhaps feeling very small under the vast canopy of stars, remember that small doesn't mean insignificant. If consciousness is rare and precious in the universe, then every conscious being is invaluable. You are the universe's way of understanding itself, of appreciating its own beauty, of wondering at its own mystery. And if we're not alone, if other consciousnesses are out there wondering just as you are, then you're part of a cosmic community of wonder, connected across impossible distances by the simple fact of being aware. The discovery of an alien message wouldn't solve our problems or transform us overnight. We would still be human, with all our flaws and limitations. But we would be humans who know they're not alone, who know that consciousness is not a cosmic accident, but perhaps a cosmic necessity. We would be humans with a cosmic perspective, a cosmic responsibility, and a cosmic future. The message from the stars wouldn't be an ending, but a beginning. The beginning of humanity's true space age, when we stop being a single planet species and start being citizens of the galaxy. As we prepare for our final contemplation, our return to the vast silence that still surrounds us, remember that whether or not we ever receive a message from the stars, we are ourselves a message. Every moment of consciousness, every act of creativity, every gesture of kindness is a declaration that the universe has become aware of itself, at least in this small corner of space and time. We are the universe's love letter to itself, written in DNA and neurons, in art and music, in science and philosophy. And perhaps, just perhaps, we're not the only such letter, and one day we'll discover others, creating a cosmic library of consciousness that enriches the universe beyond measure. The silence of the cosmos has been our companion throughout this journey tonight. We've explored the possibilities of interstellar visitors, contemplated messages encoded in mathematics and light, imagined how the discovery of alien intelligence might transform our world. But now, as we approach the end of our contemplation, it's time to return to that silence, not with disappointment or loneliness, but with a deeper appreciation for its beauty and meaning. The silence that remains, even after all our speculation and wonder, is not an empty void, but a canvas of infinite possibility, a space where mysteries dwell and where the future is still being written. As you settle deeper into comfort, perhaps feeling the gentle rhythm of your own breathing, the soft embrace of darkness around you, let's reflect on what the cosmic silence really means. It's tempting to think of it as an absence, a lack of something we're searching for. But what if the silence is itself the message? What if the quiet of the cosmos is teaching us something profound about the nature of existence, consciousness, and our place in the universe? Consider first that the silence is not absolute. The universe is full of sound, if we define sound broadly as vibrations and waves carrying information. Radio waves from pulsars pulse through space with clockwork precision. Gravitational waves from colliding black holes ripple through the fabric of space-time itself. The cosmic microwave background radiation whispers the story of the Big Bang in every direction. The universe is singing constantly. We've just only recently learned how to listen. The silence we perceive is really just the absence of one particular type of signal, the intentional communications of other technological civilizations. But even this absence tells us something important. It tells us that intelligence, if it exists elsewhere, is either rare, quiet, or communicating in ways we haven't yet learned to detect. Each of these possibilities carries its own profound implications. If intelligence is rare, then we are even more precious than we imagined, carriers of a cosmic rarity that must be preserved and nurtured. If intelligence is quiet, then perhaps there's wisdom in that quietness, lessons about sustainable existence that we have yet to learn. If intelligence is communicating in ways we can't detect, then we have so much more to discover, so many more ways of understanding the universe that await us. The silence also gives us space to develop at our own pace, to make our own mistakes and discoveries, to write our own story without interference. Imagine if the cosmos were noisy with alien signals, if we were constantly receiving messages we couldn't fully understand, technologies we weren't ready for, philosophies that challenged everything we believe. It might be overwhelming, paralyzing even. The silence gives us room to breathe, to grow, to become whatever we're meant to become without the pressure of cosmic expectations. There's a beautiful patience in the cosmic silence. The universe has existed for 13.8 billion years. Our galaxy has been around for nearly as long. Stars have been forming and dying, planets have been spinning in their orbits for eons beyond human comprehension. And through all of this vast time, the universe has been quiet, at least to our ears. This patience suggests that perhaps the universe operates on timescales we're only beginning to appreciate. Perhaps civilizations communicate not in years or centuries, but in millions of years. Perhaps the silence we're experiencing is just a pause between words in a conversation that spans geological ages. The silence also reminds us of the preciousness of what we have here on Earth. In all our searching, in all our listening, we found nothing quite like our world. Earth remains the only known harbour of life in the universe, the only place where matter has organised itself into forms capable of love, art, science, and wonder. Every bird's song, every child's laughter, every moment of human consciousness is a break in the cosmic silence, a declaration that here at least, the universe has awakened to its own existence. We are the universe's rebellion against its own silence, and that rebellion is beautiful beyond measure. Think about what we've accomplished in the brief moment of cosmic time that we've existed. We've gone from cave paintings to space stations, from counting on our fingers to computing with quantum mechanics. We've decoded the language of DNA, split the atom, detected gravitational waves from colliding black holes billions of light years away. We've created art that moves us to tears, music that touches our souls, stories that help us understand what it means to be human. All of this in what amounts to a cosmic eye blink. The silence around us makes these achievements not less significant, but more so. We've done all of this alone, without help, without guidance, driven only by our own curiosity and creativity. The silence also protects us from ourselves in a way. If we knew for certain that advanced civilizations existed, if we were receiving their signals constantly, we might become dependent on their knowledge, waiting for solutions from the stars rather than solving problems ourselves. We might lose our drive to explore, to discover, to push the boundaries of what's possible. The silence forces us to be self-reliant, to develop our own wisdom, to earn our place in whatever cosmic community might exist. It's like a parent letting a child learn to walk on their own, standing back even though they could carry them, because some lessons can only be learned through personal experience. But the silence is not just about absence, it's also about potential. Every quiet corner of the sky might harbour life. Every star might warm worlds we can't yet imagine. Every moment might be the moment before we discover we're not alone. The silence is pregnant with possibility, heavy with futures we can barely imagine. It's the pause before the symphony begins, the intake of breath before the first word is spoken, the darkness before the dawn. Living in this silence, in this moment of cosmic anticipation, is its own kind of privilege. We are perhaps the last generation to wonder if we're alone, or perhaps the first to discover we're not. The silence also teaches us humility. Despite all our technology, all our knowledge, all our efforts to detect signs of other intelligence, we found nothing definitive. This could mean we're alone, but it could also mean we're still cosmic infants, playing with toys while the adults are having conversations we can't even perceive. The silence reminds us that there's so much we don't know, so much we might not even know we don't know. It keeps us curious, keeps us searching, keeps us from the arrogance of thinking we understand everything. As we have explored throughout our journey tonight, objects like Oumuamua and our hypothetical three-eye atlas might be breaking this silence in ways we're only beginning to recognize. Perhaps the silence isn't really silence at all, but a different kind of communication, one that uses matter instead of energy, artifacts instead of signals. Perhaps civilizations have learned that physical messengers are more reliable than electromagnetic waves, that patient, slow communication is better than trying to shout across the cosmic void. If so, then the silence is an illusion, and we're surrounded by messages we're just learning how to read. The silence also gives us the freedom to imagine. Without definitive knowledge of what's out there, we're free to dream, to speculate, to create our own visions of what cosmic intelligence might look like. This freedom has given us countless works of science fiction, each one a thought experiment about consciousness, intelligence, and our place in the universe. These imaginings aren't just entertainment, they're preparation, mental and emotional training for the day when the silence might end. Every story about aliens, every speculation about interstellar communication, every dream of cosmic connection is building our capacity to handle whatever reality might bring. There's also something deeply peaceful about the cosmic silence, isn't there? As you lie there in the darkness, perhaps with only the sound of your own breathing and heartbeat, you're experiencing something that connects you to the cosmos itself. The quiet around you mirrors the quiet between the stars. In this silence, you can hear your own thoughts, feel your own existence, appreciate the miracle of your own consciousness. The cosmic silence creates space for introspection, for the kind of deep thinking that our noisy world often prevents. The silence might also be protecting us from dangers we can't imagine. Perhaps there are predator civilizations out there, waiting for younger species to reveal themselves. Perhaps there are ideologies or technologies that spread like viruses between civilizations, destroying or transforming them in ways they didn't intend. Perhaps the silence is a shield, protecting young civilizations until they're ready to defend themselves against cosmic dangers. This is pure speculation, of course, but the silence allows for all possibilities, both wonderful and terrible. As we contemplate the silence that remains, it's worth considering that we might be living in a special moment in cosmic history. Perhaps we're among the first technological civilizations to emerge in our galaxy. Perhaps the silence exists because we're pioneers, the first or among the first to develop the ability to search for others. If so, then we have a special responsibility. We might be the ones who break the silence for others, who send the first messages that end another civilization's cosmic loneliness. We might be the elders that future civilizations look to for wisdom and guidance. Or perhaps the silence is about to end. Perhaps tomorrow or next year or next century, we'll detect an unmistakable signal or artifact that changes everything. We might be the generation that witnesses the most important discovery in human history. Every day that passes brings new technologies, new ways of searching, new possibilities for contact. The silence might be in its final moments, a historical curiosity that future generations will struggle to imagine. What was it like, they might ask, to not know if you were alone in the universe? The silence also connects us to everyone who has ever wondered about our place in the cosmos. Ancient humans looking at the stars, philosophers pondering existence, scientists searching for signals, all have lived with this same silence, this same mystery. It's one of the few truly universal human experiences, shared across all cultures and all times. The silence binds us together in our common wondering, our shared hope and fear about what might be out there. But perhaps the most beautiful aspect of the cosmic silence is that it makes every moment of consciousness more precious. If we are alone, then every thought, every feeling, every moment of awareness is unique in the universe. If we're not alone but separated by vast distances and times, then our particular form of consciousness, our specific way of experiencing existence, is still precious and irreplaceable. The silence reminds us not to take consciousness for granted, not to waste the miracle of awareness on trivial concerns. The silence also suggests that perhaps the journey is more important than the destination. Maybe the search for other intelligence, the wondering and speculating and imagining, is valuable in itself, regardless of what we eventually find. The search makes us better, makes us think bigger, makes us more cosmic in our perspective, pulls us out of our planetary concerns and reminds us that we're part of something vast and mysterious. The silence gives us a quest, a purpose that transcends our individual lives and connects us to the eternal. As our contemplation draws to a close, consider that the silence might never fully end. Even if we discover other intelligences, even if we receive messages from the stars, there will always be mysteries beyond our understanding, questions beyond our ability to answer. The universe is vast and possibly infinite. There will always be silence beyond the voices we've heard, darkness beyond the lights we've seen. The cosmic silence is not a problem to be solved, but a fundamental aspect of existence, a reminder that we're finite beings in an infinite cosmos. The silence that remains is not empty, but full of potential, full of mystery, full of beauty. It's the silence of a universe waiting to be explored, understood, appreciated. It's the silence that makes our own voice meaningful, that gives significance to our attempts to understand and communicate. Without the silence, our songs would be lost in the noise. Without the darkness, our light would be invisible. The silence is not our enemy, but our companion, our teacher, our canvas on which to paint our dreams and discoveries. And so, as you drift towards sleep, embraced by the quiet darkness. Remember that you're participating in the cosmic silence in your own unique way. Your thoughts, your dreams, your moments of wonder are ripples in the vast quiet of the universe. You're both experiencing the silence and breaking it, both alone and connected to everything that has ever wondered about its place in existence. The silence is not something separate from you, but something you're part of, a cosmic phenomenon that includes and encompasses your own consciousness. Tomorrow, the search will continue. Telescopes will scan the skies, computers will analyze data, scientists will propose new theories and methods. Perhaps tomorrow will be the day the silence ends, or perhaps the silence will continue for generations more. But tonight, in this moment, the silence is perfect in its mystery, beautiful in its potential, profound in its implications. It's a silence that speaks volumes about who we are, what we're searching for, and why the search itself might be the most human thing we do. The cosmos remains quiet, but it's a pregnant quiet, a meaningful quiet, a quiet that might at any moment be broken by the most extraordinary discovery in human history. Or it might continue, teaching us patience, humility, and the value of our own small voice in the vast darkness. Either way, the silence is not something to fear or lament, but something to appreciate, to learn from, to find peace within. As sleep approaches, as your own consciousness prepares to slip into its nightly silence, remember that you've been part of something magnificent tonight. You've contemplated the greatest mysteries of existence, wondered about intelligence beyond Earth, imagined futures we can barely comprehend. You've participated in the ancient human tradition of looking up at the stars and asking, "Are we alone?" And in asking that question, in wondering about it, in being capable of wondering about it, you've already provided part of the answer. We're not alone because we have each other, because we share this capacity for wonder, because we're united in our curiosity about the cosmos. The silence remains, but it's a silence we fill with our questions, our dreams, our search for meaning and connection. It's a silence that defines us as much as any noise could, a silence that makes us reach beyond ourselves towards something greater. And perhaps that's the ultimate message of the cosmic silence. Not that we're alone, not that we're accompanied, but that we're capable of wondering, of searching, of hoping. The silence doesn't provide answers, but it gives us the space to become beings capable of finding our own answers, creating our own meaning, writing our own cosmic story. In the end, the silence that remains is not an ending, but a continuation. It's the ongoing mystery that drives us forward, the eternal question that makes us grow, the cosmic koan that has no answer but transforms us in the contemplating. The universe might be silent, but we are not. We are the universe's voice, its consciousness, its way of breaking its own silence. And that, perhaps, is the most beautiful mystery of all, that out of the vast cosmic silence arose beings capable of recognizing that silence, wondering about it, and filling it with meaning. So rest now, embraced by the cosmic quiet, knowing that you're part of something infinitely vast and infinitely precious. The silence continues, but so does the search, so does the wonder, so does the hope that somewhere in that silence, other minds are wandering just as you are, asking the same questions, feeling the same awe at the mystery of existence. The silence that remains is not empty, but full of everything that makes us human, everything that makes consciousness valuable, everything that makes the universe worth exploring. Whether 3i Atlas or something like it ever arrives, whether we ever receive a message from the stars, whether the silence ends tomorrow or continues forever, we have already achieved something remarkable. We have become beings capable of contemplating our cosmic situation, of reaching out across impossible distances with our minds and instruments, of transforming the cold equations of physics into warm wondering about our place in existence. The silence has made us who we are, and who we are is magnificent. Small perhaps in cosmic terms, brief certainly in cosmic time, but infinite in our capacity to wonder, to hope, to search for connection across the vast and beautiful darkness. The silence remains, but it's a different silence now than when we began our journey tonight. It's a silence enriched by our contemplation, deepened by our wondering, made meaningful by our attention. It's a silence that includes all the possibilities we've explored, all the mysteries we've pondered, all the futures we've imagined. It's a silence that is no longer empty but full of potential, no longer lonely but pregnant with connection, no longer frightening but beautiful in its infinite mystery. And so our journey through the cosmic mysteries comes full circle, returning us to where we began but with new eyes, new understanding, new appreciation for the profound questions that define our existence. The silence remains, but we remain too, conscious and wondering in the midst of it, adding our voice to whatever cosmic conversation might be happening, even if that conversation is still only with ourselves. The universe has given us the gift of consciousness in the midst of its vast silence, and we give back the gift of our wonder, our search, our refusal to stop asking the eternal question, are we alone? The answer remains hidden in the cosmic silence, but perhaps the question is more important than any answer could be. For in asking it, we become more than we were, reaching beyond the boundaries of our small world towards something infinite and eternal. The silence that remains is not a wall, but a doorway, not an ending, but an invitation to continue wondering, searching, hoping. And in that continuation, in that eternal quest, we find not answers but something better. We find ourselves, conscious and curious in a universe that might be silent, but is never ever empty of wonder. Sleep now, carried by the cosmic silence into dreams that might themselves be messages from parts of your mind you don't fully understand, just as the universe sends us messages we're still learning to read. Tomorrow the search continues, the wonder continues, the beautiful mystery of existence continues. But tonight, rest in the silence, knowing that you're part of something magnificent, something that transcends understanding, but invites eternal exploration. The silence remains, and it is beautiful. And you are part of it, and it is part of you forever and always in the vast and wondrous cosmos we call home.